Hello everyone, this is Sakshi Jamgaonkar. I am a part of Persistent University technical team. Welcome you all to Overview of Python session. This session is being organized for massive online training sessions for Smart India Hackathon, and I am very happy to be a part of this entire initiative. I hope you all will enjoy the entire session. Let's start with agenda of this training session. We will be covering Python, language fundamentals, functions, modules and packages, file handling, exception handling in Python, object-oriented programming in Python, and also the various standard libraries that are available in Python. Let's talk about prerequisite for this entire training session. As a prerequisite, basic knowledge of any programming language and knowledge of Unix platform is an advantage. Let's talk about the agenda for the first part of this entire session. We will be talking about an overview of Python language fundamental. We will try and understand installing and running Python. Also, let's talk about different Python development environments. And in the same, let's talk about Python interpreters. As a part of language fundamental, in this first session, we will be talking about basic data types, variables, different data structures that are available in Python. Talking about Python. Python is an interpreted high-level programming language. Python aims to combine remarkable power with a very clear syntax, and its standard library is very huge and comprehensive to use. So what is Python? Python is an open source programming language with strong similarities to Perl, but with powerful typing and object-oriented features. Python is developed by Guido van Rossum in early 1990s, and it's been named after Monty Python. As I already mentioned, Python is an interpreted language that helps quick development of applications and helps integrating systems more effectively. It's commonly used for producing HTML content on websites. It is great for text files. It's very famous for its clean syntax and powerful extensions. It does support useful built-in data structures, to mention few of them: list, tuple, strings, dictionaries, etc. But why Python at all among all other possible languages that are available? The answer is it's very easy to learn, very easy to use, and it's been widely used for a variety of applications. It does support object-oriented and it is portable across all the platforms that you talk about. It's relatively fast. C programming language is much faster but much harder to use. Java is about as fast and slightly harder to use. Perl is slower and is as easy to use, but it is not strongly typed. Python is very much strongly typed. Python has big list of available libraries to help rapid development of large enterprise systems. Here are some of the Python features to highlight. No compiling or linking. It has a rapid development cycle. No Python data type declarations. It is simpler, shorter, and more flexible. It does support automatic memory management. It also has a garbage collection facility. It does support high-level data types and operations. It's relatively fast. As already mentioned, it does support object-oriented programming. It also supports embedding and extending in C language. It is interactive and dynamic in nature. We can also have access to an interpreter information. With all these features covered, let's talk about uses of Python. Used for shell tools, system admin tools, for variety of command line programs, for extension language work, for rapid prototyping and development, for language-based modules instead of special purpose parsers. It does support graphical user interface applications. It also supports database accesses as well. Talking about distributed programming applications, Python has been used widely. It is also used for internet scripting. Let's talk about the setup required for this Python execution. Talking about Python installation, where can I get it? Many web hosts or Unix or Linux platform machines already have Python 2.x version already installed and running on them. So check for the required version on your machine and you can start using it. If you are installing on your local machine, you can go to the specified link over here, http://www.python.org, and you can find the required version for your targeted operating system, get it installed and start executing the Python interpreter of this software. For example, the mentioned link over here is for installing Python on Windows platform with a version Python 2.7.6. Let me emphasize here, Python 2.7.x is the recommended version for this whole course learning. How can I tell if it has been installed on your machine? I can use either on Unix platform or on Windows platform. On Unix platform, you can open Unix or Linux terminal using PuTTY connection and type Python on that prompt. Typing Python here, as I am highlighting, it opens the prompt with the sign $! Same thing, if Python is already installed on Windows machine, just open one command prompt and type Python command at the prompt. If Python is installed correctly, you will be able to see the version information as highlighted here, along with the Python shell prompt provided. This kind of a prompt is called as Python interactive shell prompt. Now how I can confirm on this particular prompt? Typing Python as it gives me a prompt. The use of this particular Python prompt is to start executing your valid Python statements as shown. Just any valid Python statement as an arithmetic operation shown, 3 plus 3, just execute that. It will give you an output of that executed statement directly. No need to exclusively print an evaluated value. Or another example, you can print hello string, which prints the output of it. To come out of this particular Python shell prompt, you can press Ctrl D to come out of this. I feel, let's see a demo of this so that you will have a clear idea how this Python prompt works. Let's see an example on Unix first. Clicking on PuTTY, connect to your Unix IP address. Let me just change the setting of this so that it will be more clearly visible to you all. This is your Unix prompt. As we already mentioned, just type a command Python, giving you the Python version available on Unix platform. Here we can try out the commands which will give me an output of the executed valid command. Alright. So this is a Python prompt on Linux platform. Same thing, if I have to check it on Windows platform, let's see how I can go about. Go to Start, type Python here on Windows platform. Now since it has given me a version details 2.7.6 Python, this indicates that Python is available on my Windows system. Again, you all can start executing specific commands here. The output is shown. To come out of this, you can press Ctrl D or Ctrl Z, will quit from the prompt. One more way to ensure that Python is installed on Windows, you can just go to Windows Explorer, check Python folder is here. Within the Python folder, I can show you that executable command Python interpreter is available, the one that we would be executing or using for executing our Python scripts. With that, we concluded that Python is available either on Linux platform for the usage or on the Windows platform. If I have to write a script, save it and execute it so that we can use that particular script for the future purpose, let's understand the steps on Windows. Use any text editor to write above script in a file named as, let's say, hello_world.py extension. .py extension will indicate that you are writing a Python script. You can save that in any one of the folders. Say for example, on D folder, Python_workshop. Now to run this saved script, which is a Python script, I'll have to load this particular file through the Python interpreter that is available. So go to the current folder where the script has been saved, and you can just load your file through the Python interpreter with the command executed as Python followed with the file name with an extension .py. This will give me an output of whatever is the script written in that file. Same thing if I have to talk about on Unix platform. Open the Unix terminal using PuTTY connection as I already shown you. You can create a folder, you can create a file, save in that folder. After saving a file, to execute that script on Linux platform, make sure that file has executable permission. If not, you can use chmod command to set the required permissions and make it executable script. Once that is done, you can test the program on the terminal as the command Python followed with the file name. So to execute a Python script, let's see the very first hello world program to be saved in a file and to be executed by using Python interpreter. So as the example shown over here, you can see the very first line, something written as #/user Python. What is that? It's a shebang line. It tells the kernel to find the location of Python interpreter, and by using that located Python interpreter, the subsequent Python code to be executed. So the second line says a simple print function. Print is a predefined function to output some string at a specified console. So this shown example will print out hello world at the console. Let us see an example of this with a live demo. Go to the start option. You can use any simple text editor here. Just type in the code. Let's save this file. I am on Windows right now, So I'm just using a simple notepad++ and I saved a file with, let's say, this particular name in the required folder so that we can have all the script at one place with an extension .py. Save it. Now to execute this, I have to have a prompt open. We already have opened DOS prompt. Apart from the shell prompt that we saw earlier, now let's try and understand the execution of this file that we have written. Let me go to the folder where we have created our script. Here we can execute Python and the name of the script. So with the shebang line, it indicated the prompt from where to use the Python interpreter, and by using that located Python interpreter, execute this. This is one way. Writing a shebang line is not mandatory. You can even have a path environment variable already set. If the path is already set for your Python executable command here, so here it is, C Python 27, the folder has been already added in path environment variable. So even by using this path environment variable, your system will be able to recognize the location of Python interpreter executable command, the one that is located at this location, and by using that your script can be executed further. This is one simple execution of the very first Hello World example on Windows application, wherein we could see an output of this. Let's see the same example execution on Linux platform. We already have this terminal on Linux platform. Pressing Ctrl D, I came out of that Python prompt, the interactive prompt that I showed you to execute some of the Python script. You could have very well executed lots of examples here with the valid Python statements and could have seen an output of the whole program. But as in, for the future usage, you have to have a storage of all the commands and the entire application program in a file. That's the task for us, to come up with the file and save your program. So let's use a normal editor here. Through VI, let me create the very first program. VI, give the file name, and let's come up with the text editor wherein I can type in my program. Here it is in the insert mode. Let me start typing in. With the shebang line added, let's write some simple print statement again, which will output some command. Whatever you mention in the print function parameter will be outputted to the console. Let me come out of this text editor, save the file, come back to the Linux prompt. Here I can say again Python followed with the script name. This gives me an output to the console with the predefined print function, as in whatever we printed out. So this was a simple Hello World first example that we executed on Unix platform as well on the Windows platform, wherein we are very clear now how to use the Python interpreter that is available on your targeted machine. In the previous execution, we saw the usage of a normal text editor available on the targeted operating system. But beyond that, I would like to have some integrated development environments that may support writing of the Python scripts. One of the development environments is IDLE, idle. This provides a graphical development environment, shell for interactive evaluations. It provides text editor with color coding and smart indenting for creating Python files. It also supports menu commands for changing the system settings and running the files. You may also use another development environment provided through Eclipse. Inside Eclipse, you need to have PyDev plugin. That's a Python development plugin. Then only the Eclipse will support the Python development environment. As far as the Eclipse understanding is concerned for Python script executions, we will see a demo in some subsequent topic going ahead. But for now, to begin with, we can start using IDLE, graphical user interface, this integrated development. So you can just have a look at the window that I am trying to highlight here. This could be a kind of graphical interface provided by IDLE environment. As already mentioned in the previous slide, it will give me an interactive Python shell prompt, and also it will give me a text editor wherein I can type a file, program and execute the Python program within the entire development environment provided by that IDLE. I feel let's see one demo how to execute the scripts by using this IDLE development environment. Where is it available? Go to Start option, All Programs. You can see Python 2.7 in the Start menu here. In that, I can see one of the menu, IDLE, graphical user interface. You can also have a look at the Python manual offline documentation that is available in this window-based Python installed. For now, let's see IDLE environment. Let me click on this option. So this gave me the interactive shell prompt by clicking on that IDLE environment. So again, you can start performing all the operations here, whatever the valid statements of Python. I just performed the addition of two numbers. Evaluation of that performed, valid Python statement is executed and the value gets printed out automatically. This is about Python interactive shell prompt provided through IDLE environment. But what else? The another facility as we talked about, go to the file option here, say new file. We are into the text editor of this idle editor, wherein again I can start typing in the valid statements of Python. Every print statement will print out the value at the output console. Alright, let me save this file. Save that with some file name in the folder that got saved. Now just for the execution, I need not open the DOS prompt. I can directly execute the script within this integrated development environment supported by IDLE. I have a run option here. Run the module with the shortcut key F5 also available. execution of the script, it gave me an output of the current script here in continuation to my previous shell prompt since the window was already open. Probably I can close this and re-execute my current script. Here it is, an output. So I hope everybody is getting a clear idea about the existing IDLE graphical user interface integrated development environment that is available on Windows. So you can start using this environment that is available. I need not go for any other text editor and the prompt to execute the command line execution. All that is not required now. Simply write here, execute here as the entire IDE support. With that demo of IDLE graphical environment, now what we would be looking at now in the next session is about Python basic fundamentals. Learning any programming language, as everybody is aware that you will have to look at learning the basic data types supported by a specific programming language. How do I define a variable? What different data structures that are supported in Python? So with that context, we will look at all these basic aspects now. Let's begin with variables. So what is a variable? It is a named piece of memory that can store a value. Python throws an error when trying to access a variable before it has been created. Say for example, as the Python shell prompt, just type y. What is y? Interpreter will not understand anything. So it will give me an error called as name error. It's a runtime error as y is not defined. So let's define a variable y is equal to 3 and let's access y, which will just output the value of that variable. So in this simple assignment of a value to a variable statement, assignment statement stores a value into a variable. A variable that has been given a value can be used in an expressions. Talking more about assignments, binding a variable in Python means setting a name to hold a reference to some object. It's always going to be a reference to some object when you assign some value or when you bind a variable in Python. So that means assignment creates a reference and not the copies. We have to be very clear with this. Names in Python do not have an intrinsic type. Objects have the types. So here in Python, I do not have any specific keywords like char, float, double, int to define any specific data type. We do not have these. Python determines the type of reference automatically based on what data it is assigned to. You create a name the first time, it appears on the left hand side of assignment expression, as for example x is equal to 3. A reference is deleted via garbage collection after any names bound to it have passed out of a scope. So with that, what are the different basic data types, values that are supported by Python? Say integer values. So I can start performing some operations like z is equal to 5 upon 2. The answer in this case will be a whole integer, just 2. Float values, you can go for a fractional values. You can define strings. For defining a string, either you can use a double quoted string or a single quoted string. For example, ABC quoted inside a double quote or a single quote. Both are the same. One more facility that it provides is unmatched ones can occur within the string. As in, if you have a double quoted string, inside a double quoted string you can have a single quote and vice versa. One more special thing that Python supports is triple quoted string. Use triple double quotes or triple single quotes for multi-line strings or strings that contain both single and double quotes inside them. For example, here at the beginning I have a triple quoted quotation, at the end also I have a triple quotes, and inside that you can have both of them, single quote and double quote specified, which wasn't possible earlier here, specifying both single quote and the double quote inserted between the double quote, but the same thing now can be achieved inside triple quotes. With the variables, data types understanding, let's try and understand what are the different naming rules that I have to follow. Names are case sensitive. They cannot start with number. That's a normal rule like any other programming language. They can contain letters, numbers and underscores. For example, I have highlighted some of the valid identifiers that I can use in my script. Identifier is name to a variable. There are some reserved keywords like and, assert, break, class, continue, def, del. For else if structure, I have the keyword called as elif, which is specific to Python, else, except, exec, finally, for, from, global, some specific keywords like lambda, which is something specific in Python, which we are going to see in detail in upcoming topic in detail. Raise, try, while, pass is another one more specific keyword in Python. What I want to highlight here is these are all reserved keywords. The one are not to be used for specifying a variable name, for specifying a function name, for specifying your file name. Do not, as a different data value supports on a numerical values, you can start performing some operations through some built-in Python functions, as in int of some parameter converts x to an integer, float on x converts x to the floating point value. So there are a lot of predefined functions that are available that you can start executing on numerical values. As a part of basic language fundamentals, we talk about some operators that are available in any programming language. Python also supports some set of operators. Some of the operators could be unique to you here in Python, but majorly most of them they are similar to C or Java programming language. To categorize the set of operators, I have arithmetic operators, relational operators, assignment operators, logical operators, then we have bitwise operators, membership operators, we have something called as identity operators and conditional operators. When you start performing some operations on the basic data type values, operands in Python, we come across some Boolean values like true and false. These are constants in Python. Other values that are equivalent to true or false are, under the false category I can say 0 or a specific keyword none value in Python is actually equivalent to a false value, or any empty container or object which might give me a false value. True corresponds to, that means there is some value, a non-zero number or a non-empty object containing some value, that's a non-empty object. Talking about comparison operators, these are very much familiar operators to you all. Equal, equal, not equal, less than or equal to, etc. For example, the way we start executing in an expression, x equal y. Is it so? Equality, comparator operator is what we are checking. If it is so, it returns me Boolean true value in Python if both the values are same for x and y. Talking about set of logical operators, be aware the alphabetical words a and d and or and the keyword not, they are the logical operators. Say for example, there are two operands a and b. So if a is true and b is also true, then a and b, this is an expression, valid expression in Python, it will return me true. Likewise, if a is true, b is true, then a or b, it's oring, either one of them is true, of course it's going to return me true. If a is true, then not of a returns false, not, negation. So this is about and or not keywords that are available as logical operators in Python. Just to conclude on the set of arithmetic operators that we have in Python, here is the table that describes some simple examples. Let's assume here variable a operand holds the value 10 B holds the value 20. So with that, probably you can just quickly have a look at these operators. Plus, for addition, A plus B will give me 30. Minus subtraction, A minus B will give me minus 10. Multiplication, A star B will give me 200. Slash division operator, wherein if I perform B divided by A, that is 20 divided by 10, will give me 2. Percentage is a modulus operator. So performing on B modulus A will give me 0. Star star is an exponent operator. So A star star B will give 10 to the power 20. And a unique operator in Python, 2 slashes, is called as a floor division. So 9//2 is equal to 4 is an example that I can highlight. The next table shows few examples of combinations of different assignment operators. As a normal assignment that we already saw in the previous examples, it's a simple assignment. So I can say on the left hand side some operand C is equal to A plus B, that will assign value of A plus B into C. Plus equal, which is also called as a short assignment operator, it is to do with addition and the assignment back. So if I say an example, C plus equal A is equivalent to say C is equal to C plus A. So rather than writing this whole expression, we would be preferring to write C plus equal A, as it is these kind of a short assignment operators, they are fast for the execution, is what it mentions. Similarly, you can have the different all short assignment operators like minus equal, star equal, hyphen equal, percentage equal, etc. This next table shows about some more comparison operators. Equal equal checks if the values of two operands are equal. So we generally say if A equal B, assuming the previous values A to 10 and B to 20 is not true, it will go to the false value. Not equal, check if the value of two operands are equal or not. Here is something unique in Python. Less than and greater than operator. It checks if the value of two operands are equal or not. If the values are not equal, then condition becomes true. So in short, equivalent to, not equal to operator, the negation. So this will return true if the values are not same. Greater than sign operator checks if the value of left hand side operand is greater than the value of right operand. Say for example, A greater than B is not true, recollecting the values A 10, B 20. This is a condition. As I already mentioned, and, or, not, these are the logical operators. So if I have to sum up with all this, looking at an example here, x is equal to start performing some arithmetic operation. At the end I have written something after hash. Anything that you write after hash is a single line comment in Python. Start assigning a string, since we talked about a string data value, fractional value. You can start writing the conditional statements, the control structures that are provided in Python. Let's see one demo to talk about all these data values, variable declarations, performing some operations on the values, so that we'll have a clear idea about the data variable declarations and performing some operations on them. Have a habit of writing the comments either in a hash single line comment, or you can start putting something called as a docstring. We'll talk about more in detail about this docstring, but to begin with the usage of this docstring, triple quoted string, you can start typing anything here which will be actually a comment block. So these two lines will not be subjected for the execution through the Python interpreter. We have some variable declarations here. X is equal to 100, Z is equal to some fractional value, Y is equal to a single quoted string. So you can go for a quoted string as single quote or a double quote. Then we have a conditional statement here. And here is what that indented block that I wanted to talk about. Here is a text editor of the idle editor that I am using. This supports the smart indentation automatically. I don't have to do that manually. What I mean by that? Here it is. let me put a colon. So this is instead of your curly bracketed block is what you can visualize. So here it is the indented block that I want to start with. For this if condition, if a single statement to be executed, if the condition goes true, you can write that one single statement here itself, for example. But if at all a multiple line code block to be executed for this if block, you need to go to a next line. Here it is. I repeat again, pressing after this colon indented block notation, pressing enter, can you just check that? It goes to a specific one indented block from the left hand side. It is not at the same level of if. It has gone one level inside, that is one block indentation. So at that one level block indentation, I start typing in my code block to be executed for that if condition, if it goes true. So this code block suit is for the true condition. So what am I doing? I am incrementing the value of x, so x becomes 100 at this place. I am concatenating word to the value of y. So here it is to mention plus acts as concatenation operator for a string in Python. Going ahead. Now pressing enter for every line of this code is going to be on the same indentation block, right? But what if I want to say that I am done with my if block code? So what you need to do is, you need to go back one level de-indentation block. Just press the backspace. We'll go back to the same level of your if starting point. This indicates that you are done with the code of that if block. And at that one de-indented level, you can start typing in, say for example, I directly wanted to go for else condition. Else is what? If this condition is not satisfied, the else block to be executed. So inside the else block with the indented statement, though I have a single line, as a better practice, I write a block expression on the next line. Again pressing enter after this, it is in the same indented level. Go back one level de-indentation, and at that back level you can proceed with your further program. So this is something new to you about talking about indented block, which is must. If we do not follow the indented block, hold on, we'll see what happens. What kind of an error is reported by Python interpreter. Alright, the value that got changed in x was 101 and y got changed to the updated concatenated value hello world. So let me print that. X is 101, y is hello world. You can cross verify at the output. One more point. Z was fractional value. I want to convert that to int. Let me execute a predefined function int. So executed function on a passed parameter returns me some value. What am I doing with that return value? We are just printing it. So output of that int function will be printed out. Likewise, float is executed on a x value. It will give me an output as a float value. So it converts x value into a float value, whatever will be the value of that. So here it is, executing the script. Save this and execute it. As I see, printing the x value here at this line, it gave me 101, y gave me hello world, and int of that value, fractional value 3.45, it gave me only the integral part of it, that is 3, and float of that value is fractional value 101.0. I must change the comment statement. It's not 100.1, it's 101.0, right? This is about basic data types, the variable declarations, and performing some operation on these basic data type values. Let's go back to the next slide here, topic wise. Now let's see different Python data structures supported. As the way data gets stored, different data structures are categorized. For example, under the sequence type, we have string, list, and tuple. If you have to talk about some association value storages, Python gives you dictionary. Talking about the sequence type, the very first one that it talks about is list, then string, and then tuple. What is a tuple? Tuple is immutable ordered sequence of items. It may also contain the mix type, including the collection type. Strings are also immutable. So to conclude here, string and tuple both are immutable. They cannot be modified and both are sequence type, having a collection of mixed type of values. They need not be of the same type as in array demands. Going ahead, one more third type that we have is list data type. Even this is a sequence type. Much of a syntax wise, operation wise, lists are similar to tuple. Only the difference that I can highlight here in list is mutable ordered sequence of items of mixed types. So just to conclude on, strings and tuple, they are immutable, and list is something mutable, the one that can be updated, modified. You can just delete some values, you can insert some values, you can append some values, lot of operations that can be performed on list. Then in that case, why at all two types, list and a tuple provided? Hold on, we will see that in detail. So with that, quickly browse through what all the things that are supported by string data values. Basically, string is an ordered collection, as we already mentioned about it. It is a collection of characters that stores and represents the text-based information. Strings in Python are immutable sequence. To highlight it once again, say for example, here the example that I have highlighted, x is equal to hello, and then I perform the concatenation as x plus there, and I reassign it back to x. It looks to be as if you are modifying the value of x, but to mention about a different object reference is created. That earlier x was pointing to another memory location, and this concatenated value hello there gets pointed to another memory location. So with that context, I follow the feature immutability. String is immutable, though it looks to be as if the things are changed in x. Original memory is not changed. The value gets placed into a newly allocated memory location. There is no char type in C++ or Java. Plus is overloaded to do the concatenation in Python. As already we have seen an example, you can start using a single or double quotes or triple quotes for multi-line strings in Python. Just a quick revision on this with the single quote, double quote and the triple quote. Single and double quotes are interchangeable here as both are same. There is no exclusively any specific difference as such. Empty literals values can be specified as empty string just by using the single quote or a double quote notation. It allows you to embed a quote character of the other type inside a string, as in double quoted string nights may have a single quote embedded within it, and vice versa here. Python automatically concatenates adjacent string as shown below here. Even if I exclusively don't use a plus operator, the adjacent different types of double quote, single quote, double quoted string, they actually automatically performs the concatenation. Talking about triple quoted strings, they are useful for programs that will help me to output the strings with the special characters such as quote characters. Triple quoted string also used for large block of text, because triple quoted strings can span the multiple lines as they are. By convention, docstrings are triple quoted string. As in the previous demo I highlighted, at the top I had given some triple quoted docstring. So that is called as a documentation string. So for the purpose of documentation, looks to be a kind of a comment block for you that works as a documentation string for you. So triple quoted string is used for performing the docstring. That's the first usage. And secondly, as we already saw, a triple quoted string will help me to embed any type of a quote within it, single quote or a double quote. So that way I can start using triple quotes. Talking about escape sequences in Python, escape sequence is a special bytecode embedded into string that cannot be easily typed on a keyboard. Say for example, backslash with one character is replaced by a single character in the resulted string. So if at all I have to have a backslash itself to be printed, I would say backslash backslash. Backslash n is a new line character, backslash t is a horizontal tab, as everybody is aware of this. Say for example, a string, even if I have a single quoted string with these specific escape characters /n /t, printing that s, what would I see? I will see a, then the new line character, then after b there is a tab, and then there is c. So printing s is going to give me those exclusive new line characters and the tabs with their resolved values. At times I need to have some provision of escaping these special characters. I don't want to have the meaning of /n as a new line, I don't want to have the meaning of /t as a tab, then I might go for a raw string facility provided by Python. What is a raw string and why do I need that? For example, here this first print statement, say for example some path is what I am trying to print, /temp folder / the file called as new.txt is what I am trying to print. What will happen now if I print that as it is? It will have that /t resolved as a tab. So after I'll see a tab, then emp, then a new line will be embedded, and after that just ew.txt will be printed. But whereas my purpose was to print this as a path of some file. So one solution is I can either say just escape it with that escape character //. Then in that case / will work as a normal text to be printed. So here with that escape only one / will be printed, only one / will be printed, as in the whole one path is what I will be able to see. Raw string suppress these escapes. For example, let me format some text, double quoted string, just by prefixing r. This is a provision for defining a raw string. You can go for either a small r or capital R followed with double quoted string or single quoted string. Now the same previous example, if I say print the whole path, what the difference I have just given is simply added this r prefix before the quoted string. So in this case now it will suppress the escape characters that I may have. So all the escape characters will behave as a normal text as they are. So this raw string will actually print just the path now. So I see /temp /new.txt as a normal text over here. So generally, where do I require these raw strings? Majorly when I am going to talk about file handling and some paths are to be specified, the directory paths can be specified by raw string, and majorly in the text pattern I talk about the pattern matching by using these raw strings are really helpful to talk about writing the different patterns in Python regular expression topic. Let's see one example with this. Same examples as I already highlighted on the slides. So at least for the first section you can check the output. Here it is triple quoted string facility. All the quoted strings are printed here. Once string is defined, let's start performing some operations on this string. Operations like getting one single character from a specified index. So it is the syntax provided is string name followed with a square bracketed indexing. Indexing is every character inside a string starts from the 0th index. So what I see at the third index, 0, 1, 2 and 3. So at the third index I have a character called as 3, that's an output here. There is a slicing feature provided wherein string name followed with square bracketed start index followed with the end index. So the characters between these two start and the end indexes will be retrieved. So 1 and 2 and 3, but not including that fourth index character. So it's only 1, 2, 3 that is retrieved out of this partial slicing syntax expression provided. One more expression provided, 2 here inside a square bracket, starting from the second index till the end of my string, the whole string. So it is 2, 3, 4, 5 in this example. And prefixing just before one numerical index, it starts from the beginning up to that last index 4 in this example. So starting from the beginning 0, 1, 2 and 3, but excluding the fourth index specified, it gives me 0, 1, 2, 3. So these are the different syntactical notations provided for accessing the partial string from a given one string variable. Other operations that I can start finding through some predefined methods here. len function is to return the number of characters available in that string. str of some object variable is to return a string representation of that object. Join merges the string representation of elements in a sequence into a string with separator string. Count is a useful function to find out the count of some partial string from a given one original string from the specified position till the end of your string or with a specified offset. So within that portion of a string you can find the occurrence count of a specified string parameter here. So ultimately it counts how many times str, that's a first argument, occurs in string or in a substring of string if starting index beg and ending index are provided as a parameter to that function call. Beyond these operations on a string values, would like to quickly show you some formats that are provided, like C programming language. Do you recollect? In C programming language, printf function provides me lot of formats like %d, %f, %s. So similar type of formats are provided here in Python as well. Syntax goes like this. Say for example, there is a string, I have some hard-coded text along with some variable to be printed but with some specific format. So I say the text one followed with some value to be printed. Which value? The variable I am not printing here, just the format I specified with %d followed with the word 3, and I end a string here. Post that string I just demark the notation as percentage and put a hard-coded value 2. So that hard-coded value 2, where will it be placed? At the %d format that I have specified. So it's in a sequence. Multiple values can be specified with the comma separated after this percentage, but those many value corresponding, I should have the format specifier fields here. So in this simple output I can see the word one followed with the numerical element 2 with the placement of %d and followed with the existing same comma three string as it is. Same thing here, %d, %s, two format specifiers I have given. So two of the values, one will be placed in a sequence in the first specifier and going ahead sequentially 3 will be placed in the second specifier. So ultimately I see the output as number 1 followed with alphabetical TWO, the content as it is, followed with the numerical number 3. So as specified, one more example here. So just to format some kind of a string outputs that you have, you can start using these format specifiers provided in Python. To sum up all these things together here, this tabular format shows you different operations that can be performed on string values. Plus concatenation is an example of concatenation. Hello *3 is an example of repetition. Hello of square bracketed 0 is to get the 0th indexed element of this string. It's an indexing example. So it will return me h. Hey, note down here, negative indexing is also supported by Python. So as we say, string is a collection of characters as a sequence data type. H is at 0th index. Likewise, in a reverse direction I can start counting O at -1, second last character L at -2, this next L at -3 and so on in a reverse direction. So negative indexing is what Python support for all your sequence type data values, for string, for list, for tuple, for all of them. So for here in string, getting string of -1. In all these examples, I am just applying these syntaxes on a hard-coded values. Same thing can be applied on the variables also. If you have a variable, say str, what will I write? Str of square bracketed -1 will give me the last character available in that str. Slicing, as already mentioned, 1::4 will give me a slicing. length of hello will give me a size of that string, total number of characters. Less than character comparison can be done. It will keep doing the comparison character by character, and accordingly it will give me a respective Boolean return value. There are some specific operators like in and not in Python. So I can check, is E in hello? Yes, it's there. So it will return me true. So in is a kind of a operator which will help me to check a partial content in a given sequence type. That can be used for all sequence type again, for string, for list, for tuple, etc. As we already covered string objects, let's talk about the next data structure that is supported by Python. The data structure is list. List is mutable sequence type object. It will allow me to store the different types of values. Like array, it need not store only the similar data type objects. Let's see the details of this list now. Lists are flexible, mutable container objects that can hold an arbitrary number of Python objects, unlike string that consist of only character data and are immutable. So strings are immutable, and list we are talking about, they are flexibly expandable, mutable objects. The objects that can place in a list can include all standard types as well as the objects like user defined objects. List can contain different types of objects and are more flexible than Python arrays. Python arrays, what are they? They are available through the external array module. There is no direct syntax as to define array here. We will be using some external module. But what it highlights here, the point is list can contain different types of objects and are more flexible than arrays, because arrays are restricted to contain the objects of a single type only. List indices start from 0. List can be grown or shrunk as per the modifications that you will go ahead on that operation on a list. They can be taken apart or sliced and put together with other lists, or they can be concatenated. What all the different operations that we can perform on list are: values can be inserted, they can be updated, or they can be removed as needed. Then what are the tuples? Tuples in Python are extremely similar in nature to list, but the only difference that I can highlight here is tuples are immutable. They can't be modified like string. A tuple is represented by a number of values separated by commas. The only visible difference between tuples and a list is that tuples use parenthesis, list use the square bracket. I am talking about a syntax, a visible difference. Functionality wise, hold on, we will see what is the difference between list and a tuple. Both these data structures, list and a tuple, differ functionally from each other in the fact that tuples are immutable and lists are mutable. To repeat again, even though tuples are immutable, they can hold mutable data if needed. Mutable, for example, list. Any set of multiple objects, comma separated, written without identifying the symbols, that is square brackets for list or a round bracket parenthesis for tuple, defaults to a tuple. What I mean by this last point is just a comma separated fields like 1, 2, 3 without any kind of a bracket. It defaults to a tuple definition in Python. Be clear on that. Having said about the definition of list and tuples, let's start about understanding how to create and assign the list tuple values. Syntactically, lists are delimited by surrounding square brackets. Creating and assigning the list are practically identical to list, with the exception of one empty tuple. Defining the empty tuple require a trailing comma enclosed in a tuple parenthesis. We'll see the example of this empty list and the empty tuple declaration. To begin with, example 1 here highlights list1 declaration. On the right hand side I have a square bracketed element. As you see that I have the mixed bag here of the elements: numerical value 123, a string ABC, a fractional element 4.56, etc. If I print the whole list, it will print the entire list which follows some string representation as to define or as to display that as it is. With the square bracketed notation, all the elements are printed. So with this definition, what I see is a sequence type memory is allocated holding the first element 123 at the 0th index element, ABC string element at the index 1 and 4.56 fractional value at the index 2. As visibly as you see the definition of tuple 1 here, only the visible difference that I can see, instead of a square bracket, I have a round bracket here. Functionality wise, again, memory allocation wise, it's going to talk about a sequential storage only. So let's print the entire tuple variable. It gives me the string representation as to print all the values with the round bracketed elements as it is in a sequence. Here the example 2 shows one more definition of a list. A list may contain a inner one more list. There is no limit on going with these kind of a inner list. Printing wise, it shows the outer list having one of the elements as inner list. Same thing, tuple also can have the inner elements as individual number, string, fraction, or it even can have a inner list. Just to emphasize here once again, though the tuples are immutable, the memory cannot be changed, still it can have one of the elements inside it as the mutable object. List is a mutable, as in this mutable list object I can add some elements, I can append something, I can delete something, I can insert some values. All that can be done on this one inner element. But talking about tuple, they are immutable. In the whole memory of the tuple, I cannot do the operations like append, extend, add, insert, delete. All those operations cannot be performed on tuple, the one that can be performed on list. Example 3 highlights creating the empty list. But defining and creating an empty tuple, make sure that you have at least a trailing 1 comma separated field. So to have that, one of the elements I have to specify something called as none in Python. So defining an empty tuple, printing of it, it will print the same output again. Once you define a list or a tuple, next is operations to be performed on list and a tuple. So first is how to access the values in list and the tuple. So values in list and tuple can be accessed by using the square bracket with an index specified in it. Same like string examples that we saw earlier. Trying to access a value by specifying an index out of range result in an index out of range Python error. So if there are only 3 elements, so indexes are 0, 1 and 2, and you try to access the element of 3rd or 4th or 5th index is a runtime error. So accessing the element of tuple or accessing the element of list, syntax remains the same. The list name followed with the square bracketed index or the tuple name followed with the index. It will give me that nth indexed value. While accessing the values of list and the tuple, here example 2 shows slicing. The slicing that we did on a string object, same thing is applicable here also. List 2 starting from first index up to the 4th. So who is 1? ABC value is at the first index. So 0, 1, 2 and 3. So it will give me only these 3 elements up to that. Slicing, one more option, colon 3 is start from the beginning up to 3. So 0, 1 and 2. So 123 ABC 4.56 is returned. Same thing again, syntax wise I have shown an example on both list as well as tuple. In the example 4, I am trying to show you access to the inner list elements. This inner list is at which index? 0, 1, 2 and 3. So 3rd indexed element is one inner list. Of that inner list, I want to get one of the inner element. How do I do that? List 4 followed with 3. This gives me the inner whole list. Of that whole list, getting me the first indexed element is the element list. So it will return me list. Same syntax is applicable for tuple as well. A list name followed with the square bracketed only colon syntactical notation gives me a copy of the same existing list, the whole list, slicing. Same thing is applicable for tuple again. Tuple with the round bracket definition, getting me a tuple of square bracketed colon will give me the whole list. Some of the functions now that can be used to perform some operations on list updations. Append is one of the functions. Before append, here the example 1 shows replacing a value in a list. Pick up a indexed element and just assign a value. What was there initially at the second index? 0, 1 and 2. So in place of 4.56, I'll have the string value float replacer. Example 2 shows here with that append functionality. Append will append one object with the appended element here. So either you can append a single value or I can append another list. If I append another list, that whole list will go as a one object here, as an inner list. Anyway, in this example, appending one single value, 123 ABC 4.56, just one value has been appended at the end. You can even insert the values at a specific position. The method is insert. How are we executing these methods? The list dot insert method. Over an object you execute a predefined function. Insert method takes two arguments. First argument is an index and the second argument is a value to be inserted. So what will happen? 0, 1 and 2. Here is the second position. So at the second position C will be inserted and whatever the previous value was there at second index will automatically shift towards right. So your entire list has been expanded now. Output is this. You can even insert a specific value at a negative index also. But be clear, how is that? If I specify insert at -1 to 34 value, it will insert 234 just prior to that -1. So what is that? At -1 I have 4.56. Prior to that, at that place it will insert 234. Not exactly at the position of -4 in this case, with the negative position. So here it is, 234 has gone at the second last place and 4.56 remains as it is. You can also remove by specifying a specific value. Remove 4.56. The element will be removed by which your list will be shrunk. So I get only the remaining elements 123 ABC. The way I could append some element at the end, I can even remove the last value, pop. So I say pop, which will return 4.56, as in it will be removed. The output of that function call will be 4.56 and after the removal successfully, the left out content in list 6 will be only 123 and ABC. When I perform pop on a specific index, that element also can be popped out. This parameterized pop call is also possible. Now though the heading that I have given is how to update the tuple. Hey, can I update the tuples? No, tuples are immutable. You can't. Removing individual tuple elements is not possible, though it is possible to delete an entire tuple with the del statement. This functionality is possible. So for example, I have tuple 1 with some elements, tuple 2 with some elements. Out of the existing two elements, partially by picking up them, I can form or create another third tuple. This is fine. So I say tuple 1 of 0 is 123, tuple 2 of 1 is 789. I get them into a third tuple. You can even delete the entire tuple as already mentioned. Tuple will be deleted. To expand the existing list, I have one more function, extend. Extend takes the list as a parameter, but what will it extend? It will extend that as a one object, or the elements of this list will be extended in the original list. Elements will be extended. That's the difference between append and extend. Append, it had appended this as a whole object. So inner list was appended, but the extend will extend the element wise. 1, 2, the elements have been extended. Be clear with the difference between append and extend here. You can even reverse a list. After reversing, I can see the reversed elements with that list2 variable. With list and tuples, the membership operator can be used to check if the object is a member of a list or a tuple. As we already executed the in operator on a string object in the previous table, same thing I am applying on a list. Is ABC in list1? Without writing a if statement, if I just execute this valid expression, it will return me true or false. No? If ABC exists in list1, it returns me true. And 16.0, if not in tuple 1, it will return me true. The concatenation plus operator can be used on two lists also. The way we performed concatenation on strings, I can do the plus operator on two lists as well. Only the point is, it does not allow to concatenate two different types even if both are sequence types. I cannot concatenate a list and a tuple, but I can concatenate two lists. Similar. Extend method that we saw earlier, that also can be used in place of this concatenation operator to append the contents in a list, but using extend is advantageous over concatenation in case of list, because it actually appends the elements of the new list to the original in place rather than creating a new list with a new memory reference from scratch like plus does. So what we are concluding, extending elements, it extends in the original memory itself, whereas the plus operator is going to create a new memory for you. It's not appending the elements of this number list inside string list. You are just performing the concatenation to get the concatenated value into another list. So be clear with all this append, extend, plus functionality difference. Alright, now let's say one more operation on list data by using a star operator. Use of this repetition operator make more sense with the strings, but as a sequence type, list and tuple also can use this star and benefit from its operation, like repetition. So as the example highlights here, example 1, a list is repeated twice with the star2 notation. So the existing 3 elements have been repeated twice. Same thing applicable in example 2 on a tuple as well. So with that, here is a conclusion on different built-in methods for manipulating list data like append, count, extend appends the contents of sequence to a list, index function which returns the lowest index in a list that object appears, insert method inserts the past object parameter into a list at a specified offset, pop method removes and returns the last object or object from a list at a specified position. Remove function will remove an object from a list. Reverse method reverses objects of list in a place. And you can use a sort function that will sort all the objects in a list, wherein you can even use compare function if given the way you want to sort the elements. With this, let us look at some examples wherein we will cover string, list and tuple operations that we just covered till now. In continuation to the string example that we saw, here is a sample code wherein I can access a string one specific index, slicing on an index, slicing with the starting index, slicing with start from the beginning up to the :4 last index. So if I look at the output of this, the second highlighted section gives me an output of the specific character or the element at a specified 0th position, slicing with the 2 notation, slicing with the :4 notation. So this is about accessing the elements from a string object. Few more operation if I have to show you here, execution point of view. Getting a length of str1, str1 contain persistent value. It will give me the total number of characters available. In the next example, I try to count the occurrence of partial substring PSL starting from the 0th position till the length of str. The formats that we just specified, here are some format just to see the output, as well as the repetition that we talked about with the star operator, and the raw string that is being generally used for displaying the raw text as it is. Just to conclude once again on the documentation string here, you can start putting in the documentation string in the form of the triple quoted block expression. As an output of this, all that can be checked. Length of str is persistent 10 characters. Count of PSL here in str is, I have 2 occurrences. Formats that I see are with the %d and %s, I have these formatted strings display. Printing hello thrice, it prints hello thrice. Then raw string, without the raw string, when I print this particular string of C\temp, it had all those tabs and the new line, all the escape characters were resolved as it is. But to remove the meaning of these escape character and just to go for the text, raw text, I have a raw string facility in Python. This is what the path is displayed. At the end, by mistake I happen to print S, so it gives me a name error. So be clear with that also. Any kind of a recognizing a name which may not have been defined, Python gives me a runtime error called as name error. One more thing I have highlighted in this example, trying to do the concatenation of x plus string AAA. Assuming x if it is a number and trying to concatenate a string value, that will not be possible. This will give me an error called as type error. So be aware with concatenation. Concatenation you can do of the similar types. Plus operator, overloaded operator, either on the 2 strings or the plus operator overloading on the 2 list. That should be fine. At this place, quickly have a look at one more example. If at all you are interested in taking the input from the keyboard rather than the hard-coded values, I have the ready-made functions called as raw input and input. Raw input will take the input as a string and input will take just as it is, whatever you type in. So if at all input is used to accept a string, and if you just type in the string without the quotes, that might give me an error. Better, let's see an output of this. For the user interactive window here, output asking for your name, let's say Sakshi. So it says hello to that keyboard input. So whatever I typed in, it was accepted as a string through the raw string or raw input method. Now here it is, enter your name, but this particular entry is by a predefined method called as input. Now let me enter the string as say ABC, same as previous entry. Hey, I get a name error here mentioning ABC is not defined. So it did not accept that ABC as a string value. So what I can do is, let me re-execute the script once again. Raw input, no issue, but just remember raw input accepts as a quoted string. Here if I accept a name, in the quoted literal value, then there won't be any error. It's successful. So majorly, input would be useful when I look for some numerical entries, let's say, then it doesn't give me any error. Error was only for a string. If I accept it without quotes, was a type error. So in that scenario, when I say raw input is accepting only the strings, But then in that case you have to be very careful. If I am using to get a number entry from the user and using a raw input for the same, then better you convert that into the int value before doing any arithmetic operations. Without that, what will happen? Num1 and num2, they are string, and doing a plus on that, we have already seen plus on the two strings is the overloaded concatenation operator. So here it is, I accept 100, accept 200, addition of both of them here with num1 plus num2 highlighted gives me just the concatenation, not the numerical operation. So better you convert that and then do the addition. All that we are assuming they are the number and then I perform the addition is fine. But before proceeding, you might as well do validations. You can find the type of a variable in Python, what type it belongs to, and according to the type of that you can proceed with the further operation. Just to cover one more simple example here on, I get a string, I try to reverse it. So one more new notation I am trying to highlight here, everybody, with the colon and the ending negative indexing -1 will give me the reversed string. My original string is str, and applying this syntactical notation of a slicing gives me a reverse string. I am trying to check the original string and the reverse string. If both the strings are same, I would call that string as a palindrome. Say for example, madam. In a forward way and in the reverse direction, both the values are same. Then I happen to call this string as palindrome, is what I am trying to check through a simple output. So let's accept reverse string is madam, palindrome. Reverse string probably, yes, visibly you can check. If I accept a string like alright. So could you see that the kind of execution I did for this purposely? I was looking for entering a number. I happened to by mistake enter a string. Normal addition through num1 plus num2, it gave me a kind of a string concatenation through the raw input. But then addition gave me a value error. Invalid literal for int function. So int failed at the runtime here. It cannot convert a string into a numerical value. At the most you can pass a fractional value which can be converted to an int. So keeping in mind, this is a value error with the invalid literal parameter to int function. So let me rather re-execute the script as the input expected, and here it is. ABC string and reverse string CBA is what I get. How did I get a reverse string? Just to conclude once again, this is a notation. And ultimately I conclude ABC and CBA, they are not equal through the equal operator comparison. So it is not a palindrome. So here is a conclusion on at least the operation on string. I hope you all will be able to do a kind of a string definition, populating the data in string object and doing a processing on a string data through lots of syntactical slicing notations that are available, functions that are available. We can start using them on a string data. In a sequence type, since further we just saw list and a tuple, quickly having a look at the output of these list and a tuple data storages. List is square bracketed definition to conclude once again. List are mutable. Tuple is immutable. I cannot modify a tuple. List can have an inner list. Tuple also can have an inner one of the elements as the mutable object. Accessing the elements by a indexing offset, everything is fine. Except one of the things that I am trying to access here, everybody, inner list 0, 1, 2, 3. At the most I have a third index, but wherein trying to access a sixth index element is a runtime error, index out error. So list is printed, tuple print representation, you can see it's a round bracketed one. Inner list is printed, a tuple having a inner list is printed. elements access is successful and any one specific element of the inner list accessing with that double square bracketed notation is working fine lastly. And here just to check on the error, check the type of error for that index position. It says that it is an index error, list index out of range. So again, programmatically you have to take care of such kind of errors. Probably going ahead with the next topic when we would cover exception handling. With that kind of a code subject, you may talk about some error handlings within the code so that runtime errors can be avoided. The first example was about only the list and the tuple definition and access to some elements. Going beyond, we looked at certain functionalities like assigning a value to a specific index, over a list appending some values, inserting some values, you can remove a value, you can pop out the element, and so on. So all different types of functionalities just to look at. A demo for the same. Append, you can have a look at everybody. Append one element, no issue. 500 has gone one element inside the existing list. But when I happen to append another square bracketed list, 600 and 700, can you just correlate to the output here? It has appended that as another inner list. So just keep in mind, append appends the object as an inner element. Few more functionalities we talked about. Reversing a list. You can extend a list. As a difference that I already explained, extend function with the same parameter as that of append that I showed you in just the previous example, this extend will extend element by element, not as a whole object, as an inner list. Then in operator checks for the existence of an element. Not in is just exact negation of that. You can do the concatenation of two lists as we could do the concatenation of two strings. Same thing is applicable for this sequence type. You can sort the elements of a list, a default sorting. Exactly. What I would want you to check here, extended list. When I extend a square bracketed 1, 2, it didn't go that as an inner list. It extended the elements individually. So with that context, be clear, append, extend is extending the existing memory location plus concatenation operator, probably it will create a separate new list for you. With all these examples, these are the different functionality methods we could conclude on a list data. As we mentioned, tuples are immutable, though we can at least refer the partial content of a tuple and create a altogether new tuple out of it. So from tuple 1 I picked up one element, from second tuple 2 I picked up another element, and with the comma separated these two elements, when I assign it to another variable on the left hand side, it creates a tuple for you. Do you recollect? I had made a statement, comma separated elements in Python, they form a tuple by default, even though I don't have a round bracket on the right hand side here. A comma separated elements defaults to a tuple to conclude. Now if I delete a tuple, the whole tuple can be deleted. That's fine. And after deleting a tuple, if you try to refer the variable tuple third, obviously it has to be a runtime error. For now, let me keep the statement so that you can at least check what type of runtime error we see. Here it is, name error. After deleting, of course, the memory has been reclaimed by a garbage collection, and trying to refer that non-existing variable has to give me a name error. And with that error, can you see that the Python code has terminated now abnormally? I do have some code post that previous print statement, but the one that is not getting executed due to the runtime name error at this line. So I had commented it purposely, and here it is. What is that last statement? A is equal to 1, 2, 3. Though I don't have a round bracketed thing, this printing A, it actually creates a tuple for you. It's a tuple. Notation wise now I can conclude round bracketed. I got it's a tuple. So you can even programmatically check the type of that variable A. Is it tuple? It's possible to check. With all these functionalities that we covered till now, would like to talk about one more facility specific to Python that we have on a list or a tuple data, about copying the existing objects into another memory location by the way of shallow copy or the deep copy. Primarily, object assignments in Python are simply object references. This means that when an object is created and when that object is assigned to another variable, Python does not copy the object. Instead, it copies only a reference to that object. Let's conclude this through an example. What is that copies only a reference to an object means? Taking an example of defining one list1 with some content. Now I assign that list1 to list2, another list. What kind of a copy is this? Is what we are trying to understand. Let's print list1, which is the original content. Here is output. Printing list2, obviously since you have assigned content wise, it has to show you the content. But what about memory location wise? Here it is, conclusion. A shallow copy of an object is defined to be a newly created object of the same type as that of original object, whose contents are references to the elements in the original object. In other words, the copied object itself is a new, but the contents are not. This can be confirmed by taking a look at the references of these two variable names, list1 and list2. I can check the memory locations by a predefined method called as id. id of list1, when I execute, it returns me a memory reference. Say assume this is a memory reference value that it returns me, and id of list2 is this. What is it concluding? When I did the assignment like this, assigning a list1 to list2, both are pointing to the same memory. So it's a copy by reference. It's the same reference memory. Both of them, they are pointing. So such kind of a assignment is called as a shallow copy. But what if by doing a copy like this, altogether I would like to have two different memory locations? So list1 should be in one and list2 should be another. In this example, what happens is, if I do any changes on list1, both will be reflected on list2 as well. So to go for that separate copy, we call that as deep copy. So how can I do the deep copy? The deep copy method of a copy module can be used to obtain a full or a deep copy of the object. It means creating a new container but containing the references to completely new copies of the element in the original object. Just simply, you are trying to keep two different object memory location. That is deep copy. But then how can I do it? I have to import a module in Python. Now you might ask me, what is a module in Python? Module is a kind of a file providing some inbuilt predefined functions in it. So you can start importing a copy module. The way you import some packages in Java or the way you include some header files in C or C++, Python says that the inbuilt library set is in the form of module files. So start using them. One of the first modules that I am introducing here for you is copy module. Let's import a copy module. So what all the functionalities that are available in copy, they are available to my current script execution. One of the functionality methods of this copy module is deep copy method. As I said, a module containing functions or methods in it. So let me call a function over a module. What is its functionality? Deep copy says that pass me a parameter of one list. So this list one will be copied in a deep functionality manner. Means both these list1 memory reference and list2 memory reference will be altogether different. So here it is. When I print the ID of list1, it says some memory. ID of list2 is altogether pointing to a different newly created memory location. This is called as deep copy. So we can have a look at one of the examples here of the deep copy. Import a copy module, define a list, print the ID of list1, print the newly created new list. In a normal copy assignment, references are same. This is called as a shallow copy. Content wise, both are same. Then to go for a deep copy, I do this deep copy wherein I see newly created memory gets created. So you can check on the updations on the list1 and the list2. Two more things that I would like to highlight here. Tuple is a predefined function which allows me to convert a list to a tuple type. Vice versa, list function will allow me to convert tuple to a list. So as per your requirement, data conversion is possible between tuple and the list. In the first shallow copy, as you see here, references are same, contents are same. In the deep copy, I could see different memory locations. In the list1, I appended, here it is, 500. So list1 got changed, 500 is been appended. But after appending content in list1, list2 is unchanged. So list2 is remaining back to the old one as the memories are altogether different. In case of shallow, it would have shown you the changes across both the list1 and list2. And here is an example of converting a list to tuple, tuple is created. And converting a tuple to a list, list is created. So as per the data coming to your script, choose the relevant data structure of Python. As far as the sequence types are concerned, choice is yours whether to go for immutable tuple or to go for a mutable list. Finally, to conclude on these lists and tuples, why two different similar sequence types are provided by Python? List and tuples are very similar sequence types and primarily they differ from each other in mutability concept. Tuples are good candidate to use if sensitive data needs to be passed to an unknown function to prevent a function from modifying that sensitive data. Immutability aspect. So decision is yours whether to go for a tuple or a list as per the requirement. Lists are slower but more powerful than tuples. So here is a difference. Lists are slower than tuple, but they are more powerful than tuples functionality wise. Lists can be modified and they have lot of handy operations we can perform on them. Tuples are immutable and have fewer features. And as we already concluded in the example, list method and the tuple method are the one which will allow you to create a tuple from a list and vice versa respectively. With that conclusion of all the sequence types, let me quickly introduce you to two more data structures in Python. One is a set and second is a dictionary. So here, what is a set data structure in Python? A set is an unordered collection supported by Python having no duplicate values in it. So now how Python provides you a facility to create a set definition. So as shown in the example here, you create a set out of an existing list data, or you create a set with using a predefined code by using a curly bracketed block expression. So here it is, a list containing 1, 2, 3. You call a predefined function called as set with the list parameter passed to it, a set gets created. String representation wise, it says that set followed with round bracketed with the square list elements will be displayed on the output window. And the second way of creating a set, it says that set is equal to curly bracketed 1, 2, 3, it will create a set. To talk about set more in detail, sets are used to eliminate duplicate values within a list. So here 3 is repeated, but finally in a set memory location, it will contain only the unique elements. And keeping in mind, set is not sequential type the way strings, tuples and lists are. The way a set detects if a clash between non-unique elements has occurred is by indexing the data in memory, creating a hash for each element. This means that all elements in a set must be hashable elements. So if at all I try to create a set out of a list as 1, one more inner list, set will not be created. It will give me a runtime error called as type error mentioning unhashable type list is not allowed as a parameter. So a inner list which is unhashable is not allowed for a set creation. So you just have to keep in mind this one requirement of set creation. We can do different set operations. I have created two set variables, set1 and set2. The pipe operator applied between this set1 and set2 is called as a set union. It will have all the elements of both these union set objects, but by maintaining the unique elements. So 3 is occurring only once. Similarly, intersection of two sets by using a AND operator specifically applied on set objects gives me only the common element of these two. This is called as a set intersection. Let's quickly see one example of, you have a list with few elements, 3 is repeated so many times, but while creating a set, it will have the unique elements. Here it is. Set is created with the unique elements, no duplicate values. One more syntactical way, curly bracketed set, here is an output. Set is created. Set union gives me all the elements, but by maintaining the unique elements. 3 is occurring only once, though 3 is there repeated in both of them. And intersection gives me only a unique element set. It's not just the element return value, it returns me a set of that common element. Union also returned me a set, return value is set of those union elements. This is about just an introduction to a set data structure provided in Python. As a mapping type in Python, it provides us one more type of data structure called as dictionary. Dictionary differs from sequence type of data structure in the form of the way data is being stored. Dictionary stores the data in the form of key and a value pair. So it follows the mapping of these key and a value pairs. Keys have to be unique, and from that you can refer a key to retrieve its associated value. Let's look at the details of dictionary here. As it says that what makes dictionaries different from sequence type containers like list and tuples is the way the data that is stored and accessed. So what is the way in which the dictionary data is stored? It's random. Only the point is association is retained. Sequence types use numeric keys only, numbered sequentially as indexed offset from beginning of the sequence. Mapping types may use most other object types as keys, strings being the most common. Mapping types, we are talking about a dictionary. Dictionary is of the type mapping. Association is what I talked about. So dictionaries use keys that map directly to the values. Keys can be any immutable type, but values can be of any type. The most common data structure that maps the keys with the associated values are hash tables. Hash tables are data structures that store each piece of data called a value based on associated data item called as a key. Together, it's called as a key value pair. So in Python, dictionaries are implemented as resizable hash tables. Now how to create the dictionaries? Syntax wise, again, dictionary is also created by curly brackets. Only thing is, inside a curly bracket now, instead of a normal single comma separated element, I will be creating a mapping now. Associated key and a value pair. So here it is. Name, string which is a immutable, I am creating that as a key. Key with the associated value separated by a colon is a syntax. So one pair is name Python and the second pair is course mock. Now when I try to say dictionary 1, comma dictionary 2, just the comma separated two objects in Python, what is that we have already concluded? It creates a tuple. Comma separated elements in Python are tuples. So here it is. It's a round bracketed tuple as you see in the output line. Tuple is created. What that tuple contains? The first element is an empty dictionary and the second element is a dictionary with the two key value pairs. So this is a dictionary definition. Accessing the elements, again, notation wise is same like tuple, list and the string. Access the value of a key. Just write a dictionary name followed with a square bracketed key name now. In case of tuple or a list or a string, we were using square bracketed numeric index offset. Here it is a key indexing. What will it return? The value of name. What is the value of name? It's Python. So it returns me Python. One more example, I am trying to access a value to the key server. Is server key existing in my dictionary too? No, it's not there. So trying to access a non-existing key in a dictionary of Python is a runtime error. The error name is key error. So if you recollect till now, all the different types of Python errors that we covered were name error, type error, index error. Now here is key error as far as the topic dictionary is concerned. Some functionalities on dictionary. Dictionary has one of the predefined methods to execute, has underscore key. We'll check for the existence of a key. It will return me Boolean, true or false if it does not exist. So has key of server, is it there? No, so it will return me false. Has key of name, is it there? Yes, it's there, so it will return me true. How to update the dictionaries? Now dictionaries can be updated by adding a new entry. New entry in a dictionary will be a new key and a value pair. Modifying the existing dictionary could be overriding the value or deleting any one pair. Such kind of modifications can take place in a dictionary. Adding a new or adding an existing key replaces its value. Key must be unique. So if I say dictionary 1 square bracketed name is equal to Java, if the key does not exist, it will be created newly. But if the key already exists, it will not create the second pair as with the same name but with a different value. No, it will overwrite your previous existing key. Name was Python earlier. Now after this second line execution, name will become Java. Value got replaced. Deleting any one key value pair. Just execute a del function. Del on dictionary1 of name will delete a pair, not just the value, but it will delete the pair. So name Python, that mapping pair got deleted. So after the deletion, when I access the original variable, it contains only the remaining pair, course mock. To remove all the entries, you can clear the dictionary. But clearing the dictionary, it has become an empty dictionary. Memory is still there, but only thing is contents are empty. All the elements got cleared. Now if I want to delete the whole dictionary, you apply a del function. Now what is the difference between this clearing and deleting? Clear has cleared only the elements by keeping the dictionary empty there. But deleting the dictionary, now the whole dictionary object reference is been deleted and it's subjected for the garbage collection. That's the difference between clear and dictionary. So delete. So after deleting, you try to access the dictionary, it will be a runtime error, name error. But after clearing a dictionary, you try to access it, it will say that it's empty. Here, I am trying to access. So accessing that dictionary will give me an empty dictionary. When to use dictionary? When a logical association between the key value pair is needed, or when fast lookup for data based on a custom key is needed, or when data is being constantly modified. Remember, dictionaries are mutable. So to conclude on dictionaries, these are the different methods that I have. Clear, to remove all the elements. Dictionary.copy, it returns a shallow copy of a dictionary. Get of a particular key will get me a value of that key. Has underscore key will check for the existence of a key. Items method, very important. It returns me a list of all the dictionary key value pairs. Only the keys function will return me the existing keys. You can update a dictionary. You can just get the values retrieved from a dictionary by executing a values. So these are few of the functionality methods of dictionary data structure in Python. Now here is the next topic about control structure. This topic will help you understand what are the different control structures that are available and how you can execute different looping statements in Python. The code block in Python are identified by indentation rather than using symbols like curly brackets. Indentation part I already showed you at the very first beginning example. If loop, that's the indentation we are talking about here. Python uses the indentation as a means for delimiting the blocks of code. Code at the inner level are indented via spaces or tabs. Indentation requires exact indentation. In other words, all the lines of a code in a particular suite block must be indented at the exact same level. Indented lines starting at a different positions or column number is not allowed in Python. Each line would be considered part of another suite and would more than likely result in a syntax error. So you have to be very careful when you go for a looping or a control structure. Indentation is very well important in Python. A new code block is recognized when the amount of indentation has increased and its termination is signaled by a de-indentation or reduction of indentation matching to a previous level. Code that is not indented, that is the highest level of code, is considered the main portion of your Python script. So this is about the Python indentation. So as we are talking about control structure, the control structures like if is one of the first basic control structure. The if statement in Python is made up of three components: if, elif and else. So if and elif can keep checking the number of expression conditions. If the condition is true, then the code block after the indentation colon demarcation gets executed. Similarly, else part will be executed if the condition goes false. For example, here a is equal to 2, b is equal to 3, less than b, it will go into true. Elif condition you can check, in that case is a greater than b, if not else part. As you see, most of the syntaxes are just similar like C, C++, Java. Not much of a difference here. Only the thing is, instead of a curly bracketed block code, we go for a colon indented block to be written carefully. While syntax is, while some condition, colon indented code block. So for example here, count is equal to 0, while some condition as count less than 3, I want to keep executing something, and this something that is executed for while code block is one level indented. As you see, it has gone on a inner indentation level. And once you are done with that indentation block and you want to execute something next, probably you can go one level back at a while level. That will be your main script. What about for statement? In Python, a for loop iterates over the values returned by an iterable object, that is, any object that can yield a sequence of values. So here you need to say that I can write a for loop on a sequence type like string, list or tuple. For syntax is for, give any variable name, in operator the sequence object. Sequence object could be again list, tuple or a string. For that one element in that sequence, colon, do whatever you want to do. That's a for block code. The body will be executed once for each element of a sequence. A variable is set to the first element of the sequence and the body is executed. Then the variable is set to the second element and so on till the end of that sequence element. Here it is. I have a x is equal to a sequence type is list here. So I write a syntax as for n in x colon. So that n for the first iteration is 1.0. For the second iteration n is 2.0 and so on. And I did some kind of a calculation. If the calculation code block is only one liner, yes, you can go ahead with one liner for loop. But the code is a bigger one. For the for condition to be executed, you have to go on a next line indentation and provide that entire indented block. In addition to this for loop, for construct, there is something specific in Python called as range function. What is it? Sometimes there arises a need to loop with a explicit indices to use the position at which the value occurred in a list. If you look at the previous example once again, that value n or the variable n gives you the direct value one by one. So in this for loop, this particular syntax, I didn't have the index tracked anywhere. What if I want to have an index also, mentioning n value is at so and so index? How do I specify that? I get it through range function. The range command together with the length function can be used on list to generate a sequence of indices for use by the for loop. Here it is. What it means? I have a list with 1, 3, minus 7, 4, 9, minus 5 and 4. How many elements I have? 1, 2, 3, 4, 5, 6 and 7. I have 7 elements in a list x. So here it is. Precedence wise, length of x will be executed. The length of x is 7. So 7 is evaluated here. The one that is passed as an argument to range. What is range of 7? So range is a predefined function which will give me a incremental range sequence elements starting from 0 up to this value specified. So what is that range of 7? It will return me a list 0, 1, 2, 3, 4, 5, 6 and 7. So over that returned list 1 to 7, not 1 to 7, it's 0 to 7, I am writing a for loop. So for I in that range list, so I is starting from the beginning 0 up to 6, and there I am writing some code. So what is that now? X is something that you got an index now, 0 up to 6. Last index of the list is always 1 less than the length. Length was 7. So index is starting from 0. So the last index is 6 in this example. So I am saying this for loop will be executed 7 times starting from 0th index up to the 6th index. So I is 0 for the first iteration. So what is x of I? Is this value, no? X of I, we have already seen this notation, accessing one element of a list. So x of 0 for the first iteration will be 1. Is it less than 0? No, nothing will happen. Second element 3, x of 1 is 3. Is that less than 0? Nothing will happen. But minus 7, is it less than 0? Yes, it is. What am I saying? Found a negative number at index I. Who is an index now? 0, 1 and 2. At the index 2, I got a negative number is what I am concluding. So here is an output. Found a negative number at index 2, found a negative number at index 4 or 5. It's 5. So to conclude with, over a list, when I want to get an index as well as a value of that index, range in association with length is being used to traverse through all the elements one by one by using an index inside the for loop. So this example prints all the positions in a list where it finds a negative number. Break statement in Python terminates the control loop and resumes the execution at a next statement, just like the traditional break found in any other programming languages. The way it is used is, for example, I am writing for later in a string WORLD. Later is for the first iteration W. The moment if later is equal to L, I want to break. So it will terminate the for loop. So it will print only the characters up to L. WOR is what it says. Similar to break, I have continue. One more thing that it provides is I also have a pass statement in Python. Somewhere in the next subsequent topic, I'll highlight what pass statement is. Pass, like break loop modifier, pass is used to just to pass that particular current iteration without doing anything, is a pass statement. There is one specific functionality that is provided in Python working with the list and the dictionaries called as comprehension. A simple example of when a list or a dictionary comprehension can be used is when there is a need to construct a new list based on the elements from the existing list. So for example, syntax says a new list is equal to comprehension syntactical expression, write a square bracket, and here you write a for loop for variable in the old list, and you can even put some conditional if expression also, that's possible. For that looping, you execute some operation, some expression here. So with that execution of an expression on each and every element of this old list, whatever is the evaluated answer you get, all that gets stored into new list. For example, I have a list 1 with 1, 2, 3. So I write a normal for loop. Hey, but the way we wrote a previous for loop, we were writing a for x in that list and colon indented block. Now you did not go into the indented block. Comprehension itself is going to give you a kind of a shortcut expression which can execute some evaluation expression on each and every element of this list. So you just write prior to the for loop, prefix an expression that you want to execute. So here I am doing x star 2, multiply an element by 2. For the first iteration of for loop, what is x? Is 1. 1 multiplied by 2 is 2. Second iteration, 2 multiplied by 2, 4. Third iteration, 3 multiplied by 2, 6. So ultimately a new list has been created by performing this operation in a list comprehension. So what's a list comprehension? Syntactically provided in Python, write a square bracket and inside a square bracket execute some expression for each and every element of this list. And as a second example, don't go by the name here, dictionary 1 is actually a list only, and out of this existing list I want to create a or form a new dictionary. So for this now I go for a curly bracketed syntax predefined in Python. Now this curly bracketed talks about writing a for item in dictionary 1. What is an item? 1 by 1, 1, 2, 3, 4 from that list. By using that item, just prior to that for loop, I write some expression here to create a mapping of key and a value. So for the first element 1, the value will be created is 1 multiplied by 1 is 1. For the second element 2, its value would be 2 multiplied by 2, 4. For the third element 3, 3 multiplied by 3 will be the value. For the last element 4, the value would be 4 multiplied by 4. all these evaluations on every element of this list, I did it in a curly bracketed dictionary comprehension. These list and dictionary comprehensions are very flexible and powerful and make the list processing operations much simpler. Let's look at whatever the loops that we looked at. Just to look at the output, you can quickly have a look at these small code snippets. Appropriate if loop, elif, else, a normal if condition. Be careful on that elif, the word is elif. Talking about the next control structure, while loop that is available with an appropriate while indented block colon, follow the indented block, 5th index. As a for loop syntax, very specific in Python. For n in x, this gives me only the element. Getting the index as well as the value, I use range in association with length. As we have been talking about all this indentation, de-indentation, here it is. If you don't follow an appropriate indentation in this Python code, it gives me a syntactical pop-up error message itself. There is an error in your program, expected an indented block. So, these integrated development environments, one of them that I started using was IDLE editor, is really useful, wherein it takes care of at least one level of indentation automatically. Otherwise, in any normal editors like Notepad, Notepad++, you will have to take care of all these indentation manually. Any small mistake in it is a syntax error. Alright, this is about a simple for loop, range function along with it, and lastly, comprehension is what we talked about. So, for each and every element of a list, put that statement in a square bracket and just prefix an expression that you want to execute. Expression could be anything. Here example, we have executed a arithmetic expression. So, it's creating a multiplied by 2 elements new list. There is a predefined function on a string to convert a string into a upper. So, I decided to convert each and every alphabetical element of a list to a uppercase. So, I preferred this comprehension syntax. For I in words, I say I dot upper. So, every uppercase element will be stored in this upper words. Dictionary comprehension, for every element for x in that list, I created a key and a value pair, and the syntax change in this dictionary comprehension is curly bracket. List comprehension was a square bracketed syntax. Dictionary comprehension, to create the key value pairs, I have to go for a curly bracketed expression. Just to revise and to show you, here I am trying to show you the original dictionary definition. So, that same dictionary definition, syntactical bracket, curly braces have been picked up here to create a dictionary comprehension. So, here it is, list comprehension, multiplied by 2 for every element, a new list is created. Every element is been uppercased, new uppercase words list has been created. This example has created a squared list. Here is a squared list. Dictionary has created all the pairs for you in a dictionary with a specific key and a value associated mapping. This is a dictionary comprehension. So, that is about list and the dictionary comprehension, predefined syntax provided. Alright everybody, with that we have come to an end of our first part of the session, where we discussed about getting an overview of Python language, understanding different features of Python language, installing and running Python programs on Windows as well as on Unix platform I showed you, different development environments as we named them, IDLE, Integrated Development Environment, as well Eclipse with the PyDev plugin. If you have, we can execute the examples in Eclipse also. As a basic language fundamentals, we did talk about all the basic data types, the variable, the basic data structures like string, tuple, list, dictionary, set in Python. In the next part of the same session, we will discuss about file handling and exceptions in Python, object-oriented programming in Python, and various standard libraries that are available in Python. Welcome back. Let's get started with next topic, functions in Python. Let us learn how functions are written and how functions can be called as reusable code in Python. Let us see this in detail. Functions are the structured or procedural programming way of organizing the logic in programs. A function is a device that groups a set of statements so that they can be run more than once in a program. Functions are also most basic program structure that Python provides for maximizing the code reuse. Large block of code can be neatly segregated into manageable chunks, and space is saved by putting off repeated code in functions as opposed to multiple copies everywhere. This also helps with consistency because changing the single copy avoids the need to search for and make the changes to multiple copies of duplicated code. A Python function is a code block. Code blocks in Python are identified by indentation rather than using the symbols like curly brackets. A function in Python can be created by using the syntax as shown here. In this, function definition starts with DEF. Function name is a valid identifier and the parameter list is a comma separated list of parameter names received by function name. If a function does not receive any values, the parameter list is empty, but the parentheses are still required syntactically. The indented statement that follow a def statement form the function body. The function body is referred to as a block. The indentation matters here. Line 1 with less indentation is considered to be outside the function definition. The keyword return indicates the value to be sent back to the caller. Here is a simple syntax, def, function name myfunc, followed with the parameter x comma y and performing some operation on these local variables x star y returning a value. So in case of my function call as syntactically, my fun into bracket parameter passed 3 comma 4 passes the control to the function execution and then performed evaluation returns a value 12 in this case. Parameters in Python are call by assignment. Old values for the variables that are parameter names are hidden and these variables are simply made to refer to the new values. All assignments in Python including binding function parameter uses reference semantic. Function may return a value back to its caller or do not explicitly return anything at all, that is none value. The following function acts as a procedure returning no value or none as shown. Def hello just print something wherein we don't have an exclusive return statement. So when a function is invoked, the return value captured in a result variable is none. Function returns values either a single value or a multiple value as an object. So the following example shows a function 1 returning a list and another function 2 returning a tuple. Because of the tuple syntax of not requiring the enclosing round parenthesis, it creates an illusion of returning multiple items here. But instead of the multiple values, it is actually returning a tuple for you. Let us see a demo for this function writing and invoking a function. In this simple example, func1 def has been provided, function2 definition has been provided, giving a call to a function1. The function1 gets executed, printing in function1 and within the function1 we have invoked nested function2 call. So it transfers the control to function2, so printing in function2 and as a return value of function1 at this place which I am printing it is none value as a none return value. Instead of a return none value, you can have a exclusive return statements here. You can either return a string or you return a list. Accordingly, the return value will be captured at a calling place. So in this example, I can see that return value is a list, as we happen to return a list object. So return value is a list. Similarly, we can even talk about positional parameter passing, which are also referred as non-keyword arguments. For example, here the hello function invoked with only one parameter string Python passes that formal argument value Python, and in a position it gets captured by name variable. So name is a local variable, and whatever you can perform on that name will be within the scope of hello function. So in this case, result is again none, as the function is not returning anything. Only the point here, when I start passing the values to a function call, in this example, hello definition was looking for exactly one number of parameter. What will happen if I pass more than one argument? Here is an example, either less than one argument or greater than one argument. So you can just try out with any one statement here. So trying to execute the last statement, it gives me a type error mentioning hello function takes exactly one argument and two were given by you. So it is a runtime error not matching with the exact number of required parameters in Python. We have a default value for arguments in Python. You can provide default values for functions arguments. These arguments are optional when a function is called. So as shown in the example here, the variable names c is equal to assigned value 3 and d is equal to assigned with the string hello, they are referred as default value arguments in the function definition. So if I call a function with 5, 3, hello, 3 parameters, as the positional parameter 5 will be assigned to b, c with the default value 3 will be overwritten by 3 again, and d with hello will be overwritten with hello. So it is optional for you to provide the default values. Say for example, the last function call only with one parameter. So in a sequence positional parameter 5 will be assigned to b, but the remaining 2 parameters we haven't provided at the time of calling a function. Those will hold the default local copies here. So all these function calls are going to return 8. So this is an example of default value arguments. Similarly, you can call a function with some or all of its arguments out of order as long as you specify their names. You can also just use the keywords for a final subset of arguments. Say for example, if a function is looking for 3 parameters a, b and c, so generally we happen to pass only the positional parameter values 2, 1, 43. Instead, now I can talk about the named parameters here. They are referred as keyword arguments. So whatever was a name expected in the definition of a function as a, b, c can be used here while passing them as a parameter values. C is equal to 43, b is equal to 1, a is equal to 2, whatever the values. Sequence need not match with that of the actual definition sequence. In any random order you can pass as long as the parameter names are matching. Again, one of them could be optional. If I say only 2, then 2 is assigned to a, and then remaining c is equal to 43 and b is equal to 1. This can be passed as a value for keyword arguments. So this keyword arguments comes into picture while invoking a function. Let us see demo for this. The first one for default arguments. As we already mentioned, default arguments are in case of function definition. So here it's one of the example. To calculate the tax, I define a rate variable as some default value, say 0.2. In total, there are 2 arguments expected while invoking a function. But as it says that rate is default, it's optional. So in the first function call, I pass only one argument. So 1000 is assigned to cost in a sequence, rate is default. So the final cost will be calculated with the rate default value 0.2. But at the same time, if I call the same function with 2 parameters now, so 1000 and 0.5. So this 0.5 in a sequence will be overwritten on this default value. So now rate is no more 0.2, the rate will be 0.5, that is a overwritten value. So with that context, we can talk about default value setting in the definition. So executing this script, so for the first function call, we calculated a tax with the default value rate 0.2, and in the second function call, we calculated the cost with the past rate value 0.5. But in this case, you cannot call a function without any argument. At least one has to be passed, which is not a default variable, cost. So this function call without any parameter passing will give us a type error. Similarly, the keyword arguments that we talked about, at the time of calling a function, you can call them as keyworded argument values. So if the required argument names were title and name, I decided name is equal to ABC and title is equal to Mr. to be passed invoking the function. So sequence is immaterial. Name ABC will be assigned to this name local variable. Title is equal to Mr. value will be assigned to the local variable title here in the function definition. So without the keyworded argument function call, if I would have gone for this commented function call, then Sangeeta would have become a title and name would have become Mrs., wherein it doesn't make sense. So we decided to pass the values by keyword arguments. So this is an example of keyword arguments. Let's talk about variable number of arguments. There may be situations where function is required to process an unknown number of arguments. These are called as variable length argument list. Python functions can also be defined to variable such variable number of arguments. Variable length arguments are not named explicitly in the function declaration because the number of arguments is unknown before the runtime and even during the execution. The number of arguments may differ on successive calls. Python supports variable length arguments in two ways because function calls provide both keyword and non-keyword argument types. So first way, for non-keyword arguments, one way handles the relatively familiar case where an unknown number of arguments are collected at the end of the argument list into a special tuple variable. In a second way, for keyword arguments, this other method can collect an arbitrary number of keyword passed arguments which have no correspondingly named parameter in the function parameter list into a special dictionary variable. Let's discuss these two mechanisms. As shown here in the slide, this highlighted variable with the prefix star notation is a special tuple variable which will capture all normal additional positional parameters. And in the second way, as highlighted in this second slide, the last special variable in the list of function parameters, a variable with the prefixed star notation, is a special dictionary variable. It will capture all the additional keyword parameters. What are the keyword parameters? For example, we already seen C is equal to some value. So this keyworded values will be automatically captured into this special variable. Such many multiple keyworded arguments passed, all of them they will be captured here in this variable if there is no matching keyword argument in the list provided by you in a function definition. Let's see a demo of this. This is an example of first way of capturing non-keyword arguments as positional arguments. Here, prefixing the final parameter name A with the star causes all excess non-keyword arguments in a call of a function, that is, those positional arguments not assigned to another parameter to be collected together and assigned as a tuple to this given parameter. The asterisk star operator is placed in front of a variable that will hold all remaining arguments once all the formal arguments have been exhausted, if any. When a function is invoked, all formal, required and default arguments are assigned to their corresponding local variables. Here, the remaining non-keyworded argument values are inserted in the same order in that special tuple variable. So in this example, when this function is invoked, ABC is assigned to arg1, 123 is assigned to arg2, default value has been overwritten, and then additional excess values are captured in the same sequence in that special tuple variable. So trying to print that captured the rest variable here, we would start accessing that the rest variable. So arg1 is ABC, arg2 is 123, then that the rest variable is a tuple, round bracketed notation as you see. Same thing that you can execute in a for loop. So as far as the additional parameters are concerned, they can be of any type. Here it is, when I am passing a list, so even they can be captured here in the additional arguments. But what we will not be able to capture in that star the variable if you pass the keyworded argument. Such arg4 is equal to xyz, keyworded argument variable passing will not be captured by the rest variable. Same thing, if I have to talk about the keyworded arguments capturing, I have that second special variable star star the variable. So as shown here, star star is placed in front of the variable that will hold all remaining argument once the parameters have been exhausted, if any. In this example, arg2 is a default argument and has a default value to default b. In the case where there are variable number of extra set of keyworded arguments, these are placed into this dictionary, where the keyworded argument variable names are the keys and arguments that are their corresponding values. We are talking about this keyworded argument passing, the name of the keyword and its value. So to differentiate keyword variable arguments from the previous example non-keyword informal arguments, a double asterisk star star sign is used. So in this example, calling a function 1220 will be captured by arg1, 740.0 will be captured by arg2, and these additional keyworded argument values will be captured by a dictionary variable. So how do you start accessing the dictionary? Probably some of the functionality calls, say keys. So keys will give me ID and C. If this is a key available in this dictionary, how do you access a key of a dictionary? Dictionary name followed with square bracketed syntax, the key name. The key name is available to me through this key list. K of 0 is one of the key. So you can get a value of that key. So this is one by one element access from a dictionary, the rest variable. Variable name for this dictionary variable can be anything. Speciality about is it should be prefixed with star star. So looking at an output of this, yes, so we can talk about capturing the dictionary key and a value keyword parameter passing and getting captured through the variables the rest here in this example. Let's talk about local and global variable concept in Python. In this example, both the variables r and n are local to any particular call of this factorial function. Changes made to these variables r and n when the function is executing have no effect on any other variables outside the function. Any variables in the parameter list of a function and any variable created inside the function by an assignment are local to that function by default. They cannot be accessed outside the function. A variable can be explicitly made as global by declaring it so before the variable is used, as shown here, global A before assigning some value to it. Global variables exist outside the function and can also be accessed and changed by other functions that declare them global or by the code that's not within the function. So this global variable can be accessed outside the function also as it has been declared as global. Let's look at an example of this. In the main program scope, a variable is one string. When a function is invoked, we are trying to change the value of a, which has an effect outside also. So trying to access a after the function execution will have an effect of changed value a is equal to 1 instead of one. But the same thing is not applicable to b, as b is just a local value. So referring to B within the scope of function 1 is a local different copy than that of B is equal to TWO in the main scope. So with that context, we see an output after the function call A, which was global, the value is being changed, but B is unchanged. It's referring to the local copy here as in the main scope. Let's talk about anonymous functions using lambda. Python allows to create anonymous functions using lambda keyword. They are anonymous because they are not declared in the standard manner, that is by using DEF function definition statement. However, as functions, they may also have some argument list. An entire lambda statement, as shown here, represents an expression, and the body of the lambda expression must also be given on the same line as the declaration. So syntax for lambda is as shown here, lambda followed with some argument listing which may be optional, followed with colon with an expression to be executed for that lambda function expression. Arguments are optional, and if they are used, they are usually the part of this expression as well. So let's see one demo for this. Syntactically, lambda expression is written like this, lambda colon 1. Printing this expression, some memory is allocated to this anonymous function block code. Here it is. So printing that lambda of colon 1, it prints the whole anonymous function code block object representation at a specific memory address. Now whatever is the code block loaded in that function at so and so memory address, if it is to be referred for a future reference, we capture the output of this lambda into one of the variables, which again will talk about the same memory location. So to give a call to that as a function, we may talk about a round parenthesis. Just printing a, again it prints the same object representation of a lambda object, and giving a call to a function referred by that lambda function, it returns me true as 1. Why 1? That's the expression that I have written, 1. You may talk about visualizing here any valid Python expression execution as a part of lambda function execution. As just a use of this lambda expression, we can have a look at one more simple example here. This is a second example with the lambda with the required parameter. One parameter I have taken, and generally if that parameter is there, the same parameter is used in an expression also. So in this example, lambda whole expression is captured into a variable d. So if I have a d of value 2 is called, it will come to this particular lambda expression memory and perform whatever is the expression we have written. So it will be 2 into 2. So it returns me the value 4, the return value. So x became 4. Now I call one more another lambda statement, t of x. So x has become 4. So t of x passes the control to this lambda function referred by t object. So in this scenario, 4 into 3 becomes 12. So return value has been captured in x, which is 12. Now with that 12 value, I once again call the previous first lambda expression dynamically at the runtime, passing the value 12. So with that 12 value, 12 into 2, it becomes 24. So this lambda anonymous function returns me the ultimate value as 24. Such lambda expressions are very handy when we talk about Python functional programming. We may talk about lot of functions like map, reduce, filter, which uses these lambda expressions very widely. They are very handy for executing some block code runtime dynamically by using these anonymous functions instead of defining some user defined functions for those functionalities. This is about lambda functions. Let's get started with next topic, modules and packages in Python. Module is a file containing some code. Module is a collection of group of functions or any other objects, and the name of the module can be derived from the file name. Let us see how modules can be defined and how we can execute or how we can call the modules as a reusable code by importing those modules. So Module is a file containing the code. It's a group of functions, as I already mentioned. This allows a group of related and yet independently operating functions to be shared to take advantage of work that has been done, maximizing the code reusability. In a nutshell, Python modules are self-contained and organized piece of Python code that can be shared and reused. This shown example is for how to create a module in Python. As with functions, modules also provide the option of putting a document string. Here is a document string in the first line. The module defines a function area that calculates the area of a circle with radius r and returns the computed area. So here it is. So let's create a file with the name as maybe mymath.py, the one which is going to behave as a module for you. Now this next slide shows a continuation of the previous Python module that we created. Code tries to access the variable pi and the function called area that was defined in the module file mymath.py. But Python reports name error saying these names are not found. In other words, Python does not have the constant pi value or the function area inbuilt. So this code, as shown in the slide, imports the module mymath that was defined earlier in a file mymath.py. Let's import that with the import statement, and then it tries to access the variable pi and the function area. Python again reports the name error when trying to access the pi variable without prefixing the module name, but the code works when trying to access pi variable with the module name prefixed to it. This form of access is often referred to as qualification, that is, the variable pi is being qualified by module name mymath with the syntax mymath.py. By importing a Python module, use classes and functions defined in another file. A Python module is a file with the same name with an extension .py. Like Java import statement or C++ include statement, we have import statement in Python. There are three formats of the import command in Python: import some file, from some file import star, from some file import a specific class name. What is the difference between these three formats now? The difference is what gets imported from the file and what name it refers to after importing. So for the first command, import file name, everything in the file somefile.py gets imported in this current application. To refer to something in the file, append the text somefile to the front of its file. For example, the module file name dot my function with some parameter passing. In the second command, syntactically, from some file import star, everything in somefile.py gets imported in this. To refer to anything in the module, just use its name. Everything in the module is now in the current namespace. So for example, if you have a normal function, now I'll be able to access it just by a function name. No need to specify over a specification of module name. As far as a class based method is called, it needs to be referred over a class name. But that can be referred directly without the module name. But take care. Using this type of import command can easily overwrite the definition of an existing function of or a variable with the same name. So you have to be careful. In the third command, from some file import a specific class name, only the items class name in somefile.py gets imported. After importing class name, you can just use it without a module prefix. It is brought into the current namespace. For example, my function followed with some parameter passing is not imported, as you have imported only class name. So with that class name dot method, that is imported. Again here, take care. This overrides the definition of this name is already defined in the current namespace. Let us see one demo for this module file and how it can be imported as a reusable code. This is a module file definition. So just we have some variable, a function definition, area, Fibonacci series function definition, and I have a statement as a main block code execution. If underscore underscore name followed with underscore underscore variable attribute equals to a predefined attribute called as underscore underscore main followed with underscore underscore. When we write this module and we try to test it on its own execution, I see that the Fibonacci series is printed up to 21 and the area of the radius 5 got invoked and printed the value of calculated area. But now generally we would be interested in importing this module file in another example. So here it is. So we try to import the module file mymath and I try to access them as mymath.py, mymath.area, whatever we tested here within the same file I could access them directly, but after importing I have to access it over the module file name. So executing this now, it goes into the scope of module file and whatever you have written here, all that is available to my current scope namespace and I will be able to execute it. But only thing is at the import statement, when it actually invokes the entire mymath, the content of this code block, if conditional statement, will not be executed. So before this demarcation dotted line, I will not see any output as seen here. But only thing is in the import mymath, what I get is these printed dotted lines are getting executed here. If these function calls written without this if statement, even those would have got executed at the import level. To avoid that, generally the module files will be tested with this if conditional statement, and is to repeat again, this code block will be executed only when this current file is executed on its own. This code block will not be executed in another application when you import that file. And as we saw the different format of the import statements, this was one and this is a second one. You can say from mymath import star. So after importing, all the names are available as if they are locally available. No need to use file name mymath.py, that is not required. That can be accessed. Same thing from mymath import, if you simply import py, then you will be able to access only py directly, but no other content from mymath will be accessible. So this is about writing a module file and importing it. Where does Python look for these module files? The list of directories where Python will look for the files to be imported is sys.path. Sys is a predefined module and path is an attribute giving you the path. So you can start using sys as import predefined module sys and just get the value of sys.path. This is a path from wherein the Python will look for your module files. To add a directory of your own to this list, append it to the list as sys.path.append the path. Now with this, we can think of collecting the module files in one folder which will act as a package for you in Python. So let us quickly see one example of a Python package folder having a bundle of some module files and any other application trying to import the complete package folder. How it is done? So here it is, what I can show. Now instead of keeping the files directly somewhere, let me keep that in one named folder. Taking an example of animals folder, want to create that folder animals as a package. So this package animals, as the definition mentioned, will have a collection of different animal modules, say birds and mammals. So as a collection of these module files in a folder animal will work as a package for you. So how do we proceed? Let's come up with the bird program. Here I am just introducing writing a class in Python. So let's write a class, have some kind of a init method constructor, have some kind of a instance method. Just executing on its own, there is no error as such and there is no output also, as I haven't defined or I haven't printed anything. One more content of my package is another one more class, mammal type class animal. Again it has the same constructor, has some kind of a instance method, and let's have this collection in one of the required file that you need to create exclusively inside the package folder. The file name is underscore underscore init underscore underscore dot py. Now here you say from the mammals file, module file, import mammals class, and from birds file, import birds class. So now you have everything initialized in the init file. For now, let me delete some compiled files that I had created. So what is the package folder containing? Your module file, and the init method. Now let us test this particular package folder in one of the files called as test. So now in this testing application, I say from animals import mammals. So from the entire package folder, I am trying to import mammals. From the entire package folder animals, import birds. So they are available as if they are in the current namespace area. So mammals class can be referred directly. Mammals is a class defined in animals module file. So I created an object like this, and over an object of mammal animal type, I called a method called as print members, which was defined in the class as shown already. Same thing, over a bird object, I invoke a method print members. So things are getting executed from a package folder. So animals package folder had the animal type mammal and bird, two separate module files, and we try to import the entire package folder for you. This is how package concept works in Python. One more additional point I would like to show here. In the animals folder, if I go, now I see some additional files that have been created which wasn't there earlier. They are called as compiled Python files, PYC extension files. When I imported a module file, where did I import? In this testing program, when I imported those two module files, it created the respective file .pyc file. For the reason, whenever any application tries to import a module, every time it will not go to a source code, it will try to pick up the code from this PYC file as a compiled version. So that's about a package folder working for you. Hey, now let us start with the next topic, file handling. So there is a predefined function open which will give you the file object to work with the files in different modes like read, write, append, or even the combinations like read, write, etc. So let us see how this file handling can be done in an easy way in Python by using some predefined functions. File objects in Python can be used not only to access the normal disk files but also any other type of file that uses that abstraction. Python has built-in function open that returns a file object and that can be used for all operations on a file. Python's file object provides an abstraction that provides consistency in the behavior and its implementation. Now the basic syntax of open built-in function is as shown here. Open, file name, different access mode that we can specify as read, write, append, read-write combination, and the buffering option. This function returns a file object on successful opening of the file or else generates or raises IO error exception. In this above syntax, file name is a string containing the name of the file to open. It can be relative or absolute path. Access mode optional variable is also a string consisting of a set of flags indicating which mode to open the file with. Generally, files are opened with the mode read, write, or append RWA option representing read, write, append respectively. The other optional parameter buffering is used to indicate the type of buffering that should be performed when accessing the file. The value 0 over here means no buffering should occur. The value of 1 signals line buffering and any other value greater than 1 indicates buffered input output with a given value as a buffer size. The file modes supported by Python's open function are the same file open modules used for C library function fopen. There are other modes supported by open function that will work with Python's open function. These include the plus for read, write access and B for binary access. So this table shows the access modes for file object supported by Python. R is to read, W is for write, A for append, R plus is for file read and write, RB is for binary read, WB is for binary write, AB is for open a file for appending binary, RB plus is for open a file for binary read and write, etc. Now once the file object's open function has completed successfully and returned a file object, all the subsequent access to the file can be done using a return handle. File methods come in 4 different categories: input, output, movement within the file, which are also called as intra-file motion, and some miscellaneous methods. This table lists all built-in methods for file object. Python provides these specified built-in methods that are useful to perform file input-output operations. For input operation, the read function is used to read the bytes directly into a string, reading at most the number of bytes indicated. If no size is given, the default value is set to -1, meaning that the file is read to the end. Readline method reads one line of open file. It reads all the bytes until a new line character is encountered. The new line character is returned in the return string. Readlines function is similar but reads all remaining lines as strings and returns a list containing the read set of lines. For output operations, write function takes a string which can consist of one or more lines of text data or block of bytes and writes the data to a file. A write lines method operates on a list just like read lines, but takes the list of strings and writes them to a output file. New line characters are not inserted between each line, so if desired, they must be added to the end of each line before write lines is executed. For intra-file movement operations, seek method moves the file pointer to different position within the file. The offset in bytes is given along with the relative offset location. Tell function returns the current location within the file. Let's look at the demo for simple reading, writing into a file. Let us see the simple demo for opening from a file in a write mode. So I open my file in a write mode as specified in the argument of open. dir is a predefined function to list down all the attributes and ready-made functions available for any Python object. Now I write over that successfully opened file object. I start executing the predefined methods. One of the methods is write, f.write whatever we want to print, f.write and this. So executing this program, at least on the console now I can see, since I printed this dir of f is printing all the related attributes of file object. So as you see that lot of functions like next, read, read into, read line, read lines, write, as we already mentioned in the tabular format earlier, all these are the functions of file object. Now as an output of this, I need to check, since we opened a file in a write mode, it is created for the first time if it does not exist. If the file already exists, the content will be overwritten. So we can check that in the file handling folder probably where we have a code. Now I can check my file got created with whatever the content we wrote. With that, if we want to open a file in a read mode, here is an example. Open a file in a read mode, open another file object in a write mode targeted to another file. Assuming this data.txt exists, if it doesn't exist in a write mode, it creates the IO error. So as long as in the looping the file contains some content, would like to read all the lines one by one using a read line function. So I read it. If there is some content, I print it on the console, also in a file named as f object in a write mode. So it will go into a file called as target.txt. So one line read from data.txt is getting written into target.txt. Whenever you are done with the file object usage, don't forget to close them. So with that, whatever was the content inside the data.txt, I can see here. So we can just check that content of data.txt, here it is. Just 4 statements I have is the one that is getting printed on the console. And after closing the file handle, after closing a file handle, when I try to close my file, since there is nothing, it went into a file as at the last point. And after closing, when I try to access the closed file object, it printed as closed file object. So over a closed file object, never try to perform any operation. It will give you a runtime error. As the name not found, object has been already closed. It has to be a runtime error. Another way of reading the content from a file, maybe read number of bytes that you specify. Another function, read. Output as such, I'll see the same thing. All the characters are read one by one in a looping of while true, and all the characters are printed one after another. Instead of a line by line in a looping, you can read all the lines and get it into a list So here the data will hold all the lines of your file in the form of list. Here it is. So I wrote a for loop on that list, and every line variable is a line of your file. After reading the whole content, as you know that it is pointing to the end of the file, I wanted to go back to the seek position, say 5, absolute positioning, and from there you read the content. The content of target.txt which I am trying to read it is hello world. So I went to the 5th position, which is after hello, that is space, and from that space till the end I am reading the whole content. Since read, I didn't specify the number of characters here. So from the current position 5, I am reading the whole content till the end. So it gave me the output as world. So you can start executing seek function, tell function, etc. So these are some of the examples to check at how file handling works in Python. Let's continue with understanding how exceptions work in Python. Languages like Python, which support the raising and more importantly the handling of exceptions, empowers the developer by placing them in a more direct line of control when errors occur. The programmer not only has the ability to detect the errors but also to take more concrete and remedial actions when they occur. Due to the ability to manage the errors during the runtime, application's robustness is increased. Some of the examples shown in the earlier presentation of this course showed that what happens when a Python program crashes or terminates due to the unresolved errors. The errors that we came across like name error, type error. So it was abnormally terminating your program without handling those errors. So now Python provides a list of standard exceptions that are loaded into the interpreter as a built-in. All standard built-in exceptions are derived from the root class exception. This list shows the list of standard exceptions provided by Python. All standard built-in exceptions are derived from root class exception as already mentioned. There are two immediate subclasses of exception, system exit and standard error. All other built-in exceptions are subclasses of standard error. Some of the errors as already highlighted here, like arithmetic error, it is a base class for all numerical calculation errors. Floating point error class, it is to define the error in floating point calculation. EOF error is to mark the end of file reached without input from the built-in. IO error, failure of input-output operations. To name few more errors, index error, no such index in a sequence. So when you try to access an element from a list or a tuple or a string, out of the index which does not exist gives me this runtime error, index error. Key error, no such key in mapping. It is for dictionary. If the key does not exist and you still try to access that through some method or by a syntax, a dictionary name, square bracketed some key, the one that does not exist refers to this runtime error. We talked about name error. Undeclared, uninitialized object access gives me a name error. Value error, it's an invalid argument given. Syntax error also many a times we came across error in the Python syntax. So here, the try except statement allows to define a section of code to monitor for exceptions and also provide the mechanism to execute the handler for exception. So the syntax for the most general try except statement is shown here. Try followed with colon indented block, the code to be subjected for exceptions and handling of that exception to be done in except exception name colon indented block. Handle the exceptions here. During the runtime, the interpreter attempts to execute all the code within the try statement. If an exception does not occur when the code block has completed, execution resumes past the except block. That is, the code after this will be executed. When the specified exception named on the except statement does occur, control flow immediately continues in the handler with all remaining code in the try clause being skipped. In our example above, only IO error exception is being caught. Any other exceptions will not be caught with the specified handler. The code cannot handle any other type of error because there is no handler for that particular exception. Only one except block written for opening a file object, that is IO error only. Let us see one demo for this of exception handling in Python. As shown in the example, one function reading is invoked at the main program level. Inside a function trying to open a file object, without the try except block, if the file does not exist, it would have given me an IO error and it would have terminated without executing the subsequent code after the function. So to avoid that abnormal termination of the code due to the open failure, we try to put that open function execution in a try block. So just take care of the syntax try block. It's a colon indented block on the next line, and after the try section the code to be executed, if at all any error occurs, would like to handle that, so we write try followed with except block for IO error, and I just capture the error in a named variable as say as A, and I just take the handler action whatever we want to do. In this simple example, just to show you, I have printed a statement of what error occurred. So as there is no file called as data.txt in this current folder, open function failed, and that statement execution has thrown an error which was captured by nearest except block, and there we printed could not open a file, and printing that A, it has given me the complete description of what type of error occurred with a description. No such file or a directory data.txt. But after this handling of an exception, what happened now? If at all you have any statements after this open function, that code block will not be executed. But with this handling of the exception, you are done with the reading method. It will exit from reading and still continue with your further code after reading, is the meaning of this try except block, the way it works. Slide talks about you may have multiple except blocks after a try statement as shown. Try followed with except one type of exception, followed with one more except, followed with one more except. So this is an example for it. When I call a user defined function say float written by me, I pass one value 3 which is getting captured by a local variable object. I try to convert that value into float. So the first call, it is successful. Instead of a numeric value, when I pass a string ABC, and that ABC we try to convert it into a float, which is not possible. It will give me something called as value of string cannot be converted into a float value. So the float function execution throws an error as value error. So by subjecting that this statement may throw such and such type of exception, I prefer to handle that in the respective exception except block. So with this function call ABC parameter calling, it will go to the value error. Another one more type of same function but with the different parameter now. I pass a dictionary object. Now dictionary conversion to a float, object is not matching. That gives me a type error. You can have a look at the output. So trying to convert a string to a float is value error. So it came into this block for handling the exception. Converting a dictionary object to a float through the predefined function float gave me a type error. So it went into this except block. So it's printing object type cannot be converted to float. So you may have a single try followed with multiple except block. Depending on your statement throwing a type of exception, the respective except block will be executed. Try may follow with finally. Try finally statement differ from try except in that it is not used to handle the exceptions. Instead, it is used to maintain the consistent behavior regardless of whether or not exception occur. The finally suit executes regardless of an exception being triggered within the try block. So here it is. If the code inside a try block, irrespective of whether it creates an exception or not, in continuation the finally block will be executed. So here it is. So we write syntactically try followed with finally block. So what will happen here? We are opening a file in a read mode. So what will happen if the file does not exist? Here at this place, I have an example of nested try block, inner try block followed with the finally block. If the file does not exist, it has gone to the try outer block except IO error. So it did not proceed only further in the inner block. So it went directly to the outer try block except section and it said that unable to access the test file. what we can do is, in this current folder of mine, I do have, let's say in the exceptions folder, let me keep one file data there, and here if the file already exists, so obviously this statement will not throw any exception, it will continue further. Now in this inner try block, irrespective of whether the exception occurs or not, finally block will be executed. So just have a look at the sequence in which this program is getting executed. It went into the inner finally because there was no error while reading the content from that test file. File was existing. So it executed the inner finally. From that it came to the outer finally, and then it said that I am in a outer finally. So certain things as must do kind of a thing, irrespective of whether the error occurred or not, such kind of a code can be put into a finally block. Exceptions may be raised explicitly in your code through the use of raise statement in Python. The basic syntax is raise followed with exception name. After the exception has been created, raise takes it and throws it upward along with the stack of Python functions that were invoked in getting to the line containing the raise statement. The new exception is thrown up to the nearest exception catcher looking for the type of exception. If no catcher is found on the way to the top level of the program, this will either cause the program to terminate with an error, or in an interactive session cause an error message to be printed on the console. After this raising of an exception, Python allows a developer to easily define new exceptions as shown. So for an exception, you can define a class as a subclass of super exception. So this is the syntax of creating a subclass in Python. The above syntax creates a class that inherits everything from the base exception class. Python now allows to raise, catch and handle it like any other predefined exception classes. When given a single argument without catching and handling it, this will be printed at the end of the traceback. For example, if I just say raise my error, pass some information, it will just raise an error, it will give the control to the Python interpreter, prints out what error you talked about with this parameter passing some information about what went wrong, and gets printed at the console. This argument will of course be available to the handler also, as shown in the next slide. So here it is, you raise an error, you catch it as accept my error as error. So either you pass on the control to the Python interpreter as shown in the previous example, or raising your user defined exception class as shown in this next slide, you catch it in the exclusive except block as to talk about what went wrong with that user defined exception and how to capture that. So we can look at one simple example of this object creation of a user defined exception and how to capture that. So exception is a predefined class. We created a subclass of exception. You can write a code here as to initialize the myError class with some constructor as underscore init followed with underscore. You may have some kind of an instance method to describe about that error. You can override the string representation method inside a class. All that can be done to enhance the functionality of this exception class. Right now, just a sample example, we are writing a pass statement here. Definition is must, but no code is mandatory. So I write a pass statement modifier. Now in the main program, let's try and understand how you can raise an error object of your user defined exception class. We happen to say raise my error followed with some required parameter, and raising that within the same program, you can even capture it to handle the error. So here it is. It gives me the entire information about that exception object. So what is the need for this user defined exception classes? Try and visualize some of the predefined exception classes in Python, not giving a solution to what you want to call it as an error situation. You may come up with your own class as a subclass of exception. For an example, as I have already highlighted here, say for an employee data, you are developing a class called as employee. For employee, I receive some age parameter value. If the age limit that I decide is a valid age between 18 to 50, assume. So age limit below 18 or above 50 is not a valid age for me. So I want to define this scenario as a error exception. So we define a class for it, age error as a subclass of exception, wherein you can provide a functionality as in when this object gets created after raising it as an exception, what is that you would like to do? That coding can be done here. So this is a simple scenario example that I can highlight it for. creating user-defined exception classes. With that understanding of exception handling, let's get started with next topic in Python, understanding object-oriented programming in Python. Object-oriented programming in Python basically contains two entities, class definition and creating an object of this class, and in turn understand how this entire class behaves in Python object-oriented programming. So let us see all this in detail. Python is primarily designed as an object-oriented programming, having class definition here as shown syntactically. Class is defined with my class name. So traditionally a program has been seen as a set of instructions that are followed from start to finish in order to complete a task. Procedural programming puts the logic at center of the process. But as programs get more and more complex, the procedural way of development gets more convoluted and difficult to understand. This is where object-oriented programming can help a lot. In object-oriented programming, the objects being manipulated are more important than the logic needed to manipulate those objects. Object-oriented programming puts objects at a center of the complete process. Python classes, which can be used in a manner analogous to tree structures, but which can also be used in a full object-oriented manner. So here is a syntax for class definition. The class statement creates a new class definition. The name of the class immediately follows the keyword class followed by a colon with the indented code structure. So the body in the above definition is a list of Python statements, typically a variable assignment and a function definitions. No assignments or function definitions are required. The body can be just a single pass statement. After a class is defined, the class, a new object of the class type, can be created by calling a class name as a function as shown here. The process of creating an instance is called as instantiation. Say for example, just writing my class as a function call and assigning it to an instance, it created an instance of the type class my class. This example defines a class called as say hello with an initialization method in the class body and an instance variable. Let us see the demo for the same. Let's see the first example. Here we have say hello, class definition, and there is an init method written with the syntactical notation underscore underscore init followed with double underscore. The fields of an instance can be initialized automatically by including an init method in the class body as shown here. This function is run every time an instance of a class is created with that new instance as its first argument. So whenever object gets created, that instant itself is passed as an argument to the init method automatically. So this init method is similar to a constructor in Java, but it does not really construct anything. It initializes fields of the class. By convention, self is always the name of the first argument to this init method. Self is set to the newly created say hello class instance in this example when init method is run. Like Java and many other object-oriented programming languages, the fields of an instance are accessed and assigned to by using a dot notation. Here it is. If hello1 is an object of say hello class, I access one of the instance property greeting as hello1.greeting. In this class definition, greeting is the instance variable of say hello. That is, each instance of a say hello class has its own copy of greeting variable, and the value stored in the copy of greeting variable may be different from the value stored in the greeting variable in another instance. So here in this example, we created two objects, hello1. At the time of creating a object, init method got executed automatically with that instance itself passed as an argument. So we access all the instance properties as self.greeting. So we initialize some value for that instance variable inside the init method. So hello1 has got greeting. I am trying to print it outside the class. Second object is also trying to have the same greeting variable, trying to access. Let us see the output of this. So as many as objects that you created and printing an object here, hello1, hello2 printing. Hello1, as I see that, it's been created in some memory location indicating the string representation of an object is under the main program, say hello class instance has been created at so and so memory address. And I am trying to show the object representation printing inside the init scope and also outside the init method. Both the memory locations for hello1 instance, they are same. So, they are references pointing to the same memory of instance hello1. When I created the second object hello2, it's pointing to the different memory location and so on. So, this is about an example of how to define a class, how to create an instance, and over a created instance, how to access the instance variables here. Now, a method is a function associated with a particular class. In Python, methods are defined as a part of class definition but can be invoked by an instance. In other words, the path one must take to finally to be able to call a method goes like this. First step, define a class. Second step, have the methods also in it. And as a part of second step, create an instance, and finally invoke a method from that instance. So, let us see one example of incorporating a method inside a class. So, now apart from a constructor method, we have a display instance method in the class say hello. The self argument here must be present in all the method invocations in a class of Python. This argument representing the instance object is passed to the method implicitly by the interpreter when a method is invoked via an instance. So, it's just that how to invoke a display method is what I am trying to show. Over a object obj1, just call a display, and display will have that current instance automatically passed as an argument. Even though you are not passing, it gets passed here, and over that catching argument self parameter, I can start accessing what all the instance variables that we have initialized inside the init method. Now, this display method that I was looking for with the definition had no other parameter passing. So, if you try to access the method with some additional value, it has to give me a type error, because display takes exactly one argument in this example and two are provided. Why two? By default, the instance itself is passed as a first argument, and along with that in a sequence, the second argument that you happen to pass exclusively 100. So, this is not allowed. So, your parameter matching should match. So, now for parameter matching, when you want to pass the extra number of parameter, as we already saw in the previous topic of functions parameter passing, you may talk about the star variable as a tuple special variable or a star variable to capture the variable number of arguments in Python. All that remains the same with the concept of parameter passing to a function. So, here we talked about invoking a method of a class. So, now beyond a normal instance variable, a instance method, we have something called as class variable in Python. A class variable is a variable associated with a class and not to an instance of a class, and it is accessed by all the instances of the class in order to keep a track of some class level information, such as how many instances of a class have been created at any point in time. A class variable is created by an assignment in the class body, not in the init function. It can be seen by all the instances of a class after it has been created. So, here in this example, this py variable at a class level definition is referred as class level variable. So, as to check with an example of this, so as to define a circle, wanted to have a py as a class level variable because it is going to remain the same for all the circle objects. So, instead of defining that inside a init method as an instance property, we decided to go for a class level variable. Now, how do I access this class level variable? You can access that as with the class name dot that variable. No need to have an instance for it. So, outside the class also I can refer that as circle.py. That is fine. So, here this circle.py, it is at a class level. Just to access syntactically, can I access py over an instance? Yes, you can, but there is no meaning as such, because it is not a copy pertaining to any one specific instance. It is a class level, only one memory maintained variable referred as class variable. So, it's just that py value has been set with the different radiuses that you pass. Probably we are trying to calculate the area of that circle. So, as you see here in the init method from my previous example, I am trying to write a parameterized constructor. Earlier I had only self, but now at the time of creating a circle object itself, I decided let me pass a radius value. So here it is, actually two parameters are passed, the current instance plus this parameter 2. So instance is the first parameter, and in the positional parameter sequence, the radius local variable will capture the value 2 passed by you. Now we have something called as static methods in Python. Python class can also have the methods that correspond explicitly to static methods in a language such as Java. Just in Java, static method can be invoked using the class name even though no object has been created for that class. So static method can be accessed even before instantiating your class. Now to create a static method, Python provides a predefined @static method decorator definition. So here it is, just before the method definition, put up a declaration as @static method. It means that this method is no more an instance method, it will be accessed over a class level. As an example to see, so here it is, I have one of the methods called as test declared as static method with that decorator declaration. So how to access that static method? Circle.test. And within this test method, you can access the static method properties or static variables declared at a class level as circle.py. But I cannot access anything like self.radius because this static method doesn't have the instance passed to it, as static methods are nothing to do with one individual instance of a class. It is to do with the entire class definition. So this access is not possible. So again, just as an access, we are printing the py variable, area, and executing test function as a static method. Similar to static methods, Python also provides class method. Class methods are similar to static methods in that they can be invoked before an object of the class has been instantiated or by using an instance of the class syntactically. But the class methods are implicitly passed the class they belong to as their first parameter. Syntactically, to create the class method, @class method decorator is been provided. Here it is, the way we had static method declaration, the method had no class parameter passed to it. Now see the difference in this static method definition and in the next slide, class method definition. That method has one of the default parameter gets passed as a class name itself. That's the one major difference that we can highlight between a static and a class method. So now we can define the class. Instead of a complete class name, you can traditionally use the CLS as a catching argument, and through that argument parameter, you can refer the class name. So over that class name, you can start accessing the rest of the static variables of the class. As a demo to check class method, I have a same circle class enhanced now. I went for two class level variables, py variable and a class level one list that I have declared, all circles. Then I have a init constructor method, I have a area instance method, and I have a class method called as calculation of a total area. So creating one first circle object, creating the circle object and invoking a area method. Now what I do is, of that entire circle class, I access all circles static or a class level variable, assigning a list to it as a collection of two circle objects. And with that, I call total area, which anyways is a static, not exactly static, it is a class method. So when class level method is invoked, same class name is passed as an argument by default. So it is CLS is your class name. Now over that CLS, all circles when I refer, all circle is anyway class level variable, I can access it. And over that, I try to get for every circle object the area, and I am putting the area calculated value into some local variable to get the addition as total. So ultimately, this class method is referring to all your circle objects from the class level variable all circles and trying to get me the total calculated area. So this is about class level method in an object oriented programming of Python. Let's talk about inheritance. Inheritance in Python is easier and more flexible than inheritance in compiled languages such as Java, C++, because the dynamic nature of Python does not force any restrictions on the language. Inheritance describes how attributes of the base classes are inherited to the derived subclass. A subclass inherits attributes of any of its base classes, whether they are data attributes or methods. So here it is, the way of creating a parent class and a subclass. So class parent, and here is the definition syntactically, class child inheriting from super parent class. Let's see the demo of this. So we created a parent class, defined the constructor in it, we defined a child subclass of parent, and in this example I am just trying to access the object of parent and object of a subclass child and some of the properties of those classes, as the properties as in underscore underscore class followed with underscore, parent dot basis, it will give me a super class name, parent dot underscore underscore doc followed with underscore underscore attribute will give me a documentation string if it presents in the parent class. So these are the predefined attributes that can be accessed for a class object. So here it is. So we are just creating an instance of a parent, creating an instance of a child and printing some of the attributes. So as far as a parent class was concerned and trying to print the basis, there is no more parent class up the hierarchy of parent. So the super classes for class called as parent, it's empty. It doesn't have any more parent base classes, etc. So this example is just to show the hierarchy of syntactically creating a subclass of parent class. Now this slide shows an example of overriding methods through inheritance. The class parent has another function named as greet that prints out some message. The class child, that is a subclass of parent, also has the method greet. So it inherits the greet method as shown in the above example, but the class child overrides this greet method that is inherited from the class parent and it prints its own message. So if I create an object of this class child and over that object invoke a greet, obviously this overridden method will be invoked. Checking an example. So we have this greet in the parent method. We have a greet method in the subclass child also. So trying to call p dot greet, of course the super parent class greet method will be invoked. Invoking a child class method, obviously it will call the child class method. So just invoking a greet, it says that hi, I am in a parent greet. Just invoking a greet of C, of course it calls the child greet method. So one reason for such overriding method is because a subclass may want special or different functionality than its parent class. So the next obvious question then can be, can a subclass call a base class method which is overridden in the subclass? The answer to the above question is yes, as shown below. Here parent.greetC. So what I am trying to say, the superclass dot greet by passing a subclass method, then it's going to call the parent class same named method. So this way of calling a overridden method is possible from the parent class. Python does support multiple inheritance also, that is for subclassing from multiple base classes. Python supports a limited form of multiple inheritance whereby a depth first searching algorithm is used to collect the attributes to assign to the derived class. Multiple inheritance takes the first name that is found. As an example, this example consists of pair of parent classes parent1, parent2, pair of child classes child1, child2, and there is one grandchild class. Child1 is derived from parent1 and parent2. Child2 is also derived from parent1 and parent2. The child2 defines two functions, foo and bar, and grandchild class is derived from child1 and child2. As an example of this, multi-level and multiple inheritance shown here. So when I call create an object of grandchild and over that I call foo. Foo is not there in grandchild, so it will try to search for in child1. In child1 also I don't have. So in one depth level inside it will try to search in parent1. So going to parent1 hierarchy, is it there foo? Yes, it's there. So the output is called parent1 foo. Then trying to call gc.bar, again the sequence, it will go from grandchild, doesn't have bar, so it will go to child1. Child1 again doesn't have bar function, searches for in parent1. From parent1 again it is not there. So coming down again in the sequence, parent2 is being searched for bar function. Yes, it's there. So in the sequence, parent2 bar is being invoked. So like there is a kind of a limitation in which the scope of the function access is searched for. It will go in the first level depth access, and wherever firstly it is found, from there it will be executed. And one way to specify which one you want to call, as similar to the previous example, I give the superclass name, let's say child2. Child2 is a superclass for grandchild. Dot foo I call by passing the subclass object. So child2 foo method should be called. Yes, child2 foo method is there, that gets called. So in short, this is a simple example to show you how the multiple inheritance is supported in Python. Now there is a other important matter, that the two special methods which provide the functionality of constructors and destructors, namely underscore underscore init underscore underscore function and underscore underscore del followed with underscore underscore as a destructor respectively. Some of the other special methods allow for powerful form of extending a classes in Python. In particular, they allow for overloading operators like plus, star. Such kind of overloading operators can be mentioned through some overloaded methods. Secondly, I also can override the underscore underscore str method or underscore underscore repr. It can display something meaningful rather than the generic Python object string object and display an ordered pair tuple with the current data values in the object. So we can see quickly one example of such overriding methods, special methods implementation. One of the methods here is to represent a string representation and also to override the plus operator. I override the special method called as underscore underscore add followed with underscore underscore. That takes two arguments. One is a self current instance on which that will be invoked, and another is the value that you will be passing. How it works? I have a class called as opair. It has two parameters capturing. So I call opair method constructor with two values 6 and -4. So printing my pair, it will no more be a default string representation of an object, but rather it will be this string representation that we have overridden. So while printing an object, it calls this str method. So to show you the string representation of this object, here it is, my pair 6, -4. If I had not overridden this particular method, it would have given me a standard Python object string representation as that triangular bracketed class name followed with some memory address where the object has been created. Instead now it's printing the overridden string representation. Now after creating two pairs, pair 1 and pair 2, I am doing the addition of those two objects. Now it is no more a normal arithmetic plus operator, since the class of this pair 1, that is opair class, has got a additional special method overridden here, that is add method. So when this perform operation of plus operator takes place, automatically the add method is called. So this add method on the invoking object pair 1 is called. Pair 1 is passed to self, and the second argument after the plus operator is a second argument that automatically gets passed to add method. So what I am trying to say is, with this operation, add method is getting called. That's a overridden functionality, and within that I try to do the addition of two pairs, at 6 plus -5 is this operation, and the second parameter -4 plus 9, that is this operation. So we get the addition of all this. So as an output here, I get to see the addition. 6 plus -5 is 1 and -4 plus 9 is 5. To conclude here, this gives me the overriding of certain method representation. With that conclusion of the previous topic, object-oriented programming introduction, let's talk about various standard libraries that are available in Python. To list down these standard libraries, we can talk about some of the modules like OS. OS module provides dozen of functions for interacting with the operating system. Instead of the examples, what I can highlight here everybody, you can go to Python offline documentation, go to the Python manuals. Here we have Python tutorial. If you scroll down this document a little, we have a standard library documentation here. So you can just quickly refer some sample examples. OS module has some of the methods like get cwd, which gives me the current working directory. You can change the folder. You can execute a system, some command like mkdir. All these are the predefined functions of OS. Many more functionalities available, just to name few of these. Next module highlighted on my slide is SIH2018. For a daily file and directory management task, this module provides a higher level interface that is easier to use. As an example, SIH2018 module dot function call, copy file, move. These are the readily available functionalities that are available. You can start using them. Globe is another module providing a function for making the file list from directory wildcard searches. Like globe module has one of the predefined methods in it as globe to search for example, star.py, giving you the access to all the file listing with an extension .py. Sys module, it again has lot of functionalities in it. Few of them are getting the command line argument as sys.argv attribute. The other attributes like sys.stdin, stderr standard input output handles, etc. can be used. For example, with this import sys and printing sys.argv, and if this current program that I have written, if I execute as python demo.py file with two parameters that I pass as a command line argument like this is called as an execution of a Python file with a command line argument. These two values along with the file name will be available in sysy.argv parameter automatically. File name is the first value in that list. It returns me a list. RE is a module that provides the regular expression tools for advanced string processing for pattern matching. Like RE module has lot of functionalities like match, find all, search. So that will allow me to search for some pattern in a given original long string data. So in this example, we are trying to find all occurrences of, with a raw string, a word boundary content starting with F followed with any alphabetical content with a star wildcard as one or more alphabets. So this pattern will try to search for F followed with multiple alphabets. So food. Then further, as there is a find all method, it will search for FELL also. Then it will search for F followed with this fastest also. So probably we can quickly check one example execution for this one. So trying to find all this option, find all gives me all the occurrences matching to this pattern match. So a lot of pattern match rules actually simplifies your task of string handling in a much simpler way. So this is one of the useful modules to talk about string data handling in a simpler way. Many more other modules, just to name few of them here. Random is to provide the random selection. urlib to do the internet access. Date time is to give you the date, time access from this module. So all the documentation I have already shown you to get started with the using of these all standard library modules in Python. So as per your task requirement, you can just keep looking for any predefined module. If it's available in Python software, start using it. There could be some third-party vendor developed modules available as open source. You can get them installed on your machine along with the existing Python software. Even those could give you a support to lot of functionality code. As I had mentioned that we will see one example of execution on the Eclipse setup, we can do that. Let's look at the Eclipse setup. In the Eclipse option, you need to go to Windows with the preference option, and you have an install option available there. With the click on add button, you can add the Python name, and you need to enter the link for Python development environment link. And once that is done successfully, you need to go to the preferences option and select the interpreter executable command location for this. With this PyDev environment, Python scripts can be executed in Eclipse environment. Let us see how. On your machine, you can check for a Eclipse available. Say here I have a Eclipse Kepler version. Double clicking on this Eclipse startups the Eclipse environment for you. Now here PyDev environment is seen, but now this is available after installing the PyDev plugin in this Eclipse. So as already highlighted in PPT, you can go to help, install new software, click on add. Here you can give the name as, let's say, Python 2, since we are working on Python 2 version, and give the location of the internet link where PyDev plugins are available, and just say OK. With that repository plugin installation, plugin gets displayed and you can see the PyDev environment, something similar to your Java environment, the one that will support for the entire Python development environment. Now once this is done, you need to go to Windows, Preferences, and you need to go to PyDev option, which has been currently added. Under the interpreter option, add the Python interpreter location. Now since I have already added, it's seen over here. Otherwise you can say new and add the location of Python interpreter here, so that the Eclipse has the setting for Python interpreter as an executable command. Once this entire environment setting is done, you are ready for Python script executions in Eclipse. Now as far as the options are Eclipse are concerned, you can go to File, create a new Python file, or you can create a PyDev package, as we already saw how to create the Python packages. All that is possible here to create the respective folder structure. Say for example, under this I created one folder, testing, and under that right clicking I created a file, new file as a .py extension file, and the code over here, and the one that can be run as, or you can simply say run. The output console will show an output of this simple script that I have coded in Python. So likewise, you can have the entire development environment for the Python scripts execution in Eclipse. So this is about Eclipse setup. With this, let's carry out at least 1 or 2 sample assignments to talk about all the topic coverage we have done till now. Taking the first assignment, let's say I have a EMP data file provided containing some file data in it. Let's read that, display all the employee details, and I have some salary field for every employee in that file. So let's display the total salary for all the employees. So taking up this example, let me show you first that EMP data file data storage. So probably this could be a sample data for access. Here let's assume 1A is the employee ID, ABC is the name of the person, 25 field is the age of the person, and 25,000 is the salary of that person. Let me write a front-end Python script to read this entire file, display all the details of each employee, and get me the total salary for all these employees. So what I need to look for is the data reading from an employee. So open a file object, as we have already discussed today. Data storage that I decided was a dictionary. For every employee ID, this is a key, and I decide all rest of the fields as values for this particular key. So I start reading a line from FH. I do the F strip or R strip to remove the ending new line characters, and every line has a colon as a delimiter. So I split that line. So line dot split on the colon delimiter returns me a list. So list containing L1 of 0, as already shown to you, the 0th element of this list is an employee ID. So I get that into one local variable EMP ID. and then EMP data, which is the empty dictionary earlier, let me create an ID, that EMP ID in it. So how to create an ID of a dictionary? Just to do a recap, you write that EMP data of square bracketed EMP ID is equal to now L1 starting from first index to 4. What are the things starting from first index to 4? ABC, 25,000. So 3 elements list is been assigned as a value to one employee ID key. With that, when I want to traverse through each and every employee data, I write a for loop. So this I is a key. Key is 1A, 2A, assume that. So for employee 1A, for example, for the first time, the key that I retrieve is 1A, assume it. Details are. Then the dictionary is EMP data of I, that is 1A. So EMP data of 1A is your dictionary key 1A. Of its 0th location will be the name of that person. So nested, a dictionary of list, values are list now. So every individual element I am accessing one by one. So this for loop will print for one employee ID, the name, age, salary, all the fields. To get the total salary, you can get that integer value of EMP of I of 2. The last element of that employee ID is a salary field, as you see here, the last field. I get that into the total salary addition, and the total salary will be the total salary of all the employees together. So here it is. Whatever was the employee with all the details, you can cross verify with the data input. 25,000 is 1A, 30,000 is 2A, and 60,000 is 3A. Order in which the IDs are retrieved by keys function, I cannot predict. It's in some random order. Enhancing the same example, if I ask you, probably for every employee, the salary, whatever it was, let me add 5,000 to it, assuming the appraisal period. Let me increase the salary for every person by 5,000. How do I do that? So now you already know how do I retrieve the salary field. The salary field is this EMP of data of I of 2 in the for loop. Get the int value of it and add 5,000 to it. But by adding, store it back to the same field variable. Probably let me remove this comment statement. So with that, I am printing the updated EMP. With the given updated task, I updated the salary of every person. So here it is. Updated data did not get print as it was comment. Here it is. Apart from getting the total salary, I am printing the changed salaries. 1A was 25,000, it became 30. 3A was 60,000, it became 65,000. 2A was 30,000, it became 35,000. So it is just a sample example assignment wherein I am giving you an overview of given a data as an input to your script, how you would proceed storing that into an appropriate data structure and further process it. You may include the functions, you may include the exception handling and appropriately. Alright, so probably I can pick up second assignment statement here. I have a country data provided. Let me read out that country data for, say here it is. So I have every line describing about a country, some code number, the city name, continent, and then at the end I have the language spoken in that country. So I am looking for writing a Python script to read this particular example. So what is the task on this country data file? Store the country data from country file only for a language name and its count in a dictionary. So probably as you see that English is being spoken across different states or different countries. So I want to get the count of these languages. So what is that I am trying to visualize now? Country as a key to be stored in a dictionary and its value to be updated. For the first time it may be 1, second time whenever English is read once again, that count should be updated to 2. So ultimately with this problem statement, I conclude that I would like to form a dictionary and add the data in it. So let me try out a code for you here. Let's open a file object. In a read mode. Let me have a dictionary data to store the dictionary that we discussed. Let me start reading the content from a file. So for line in FH object, indented code block, then I say line is equal to line dot, we can just strip off the unnecessary ending new line characters. Now in that line, as far as the data is concerned, where is the language? As you see, it's the last field. Every field is separated by a comma. So let's do the splitting by a comma. So language is equal to line dot split function we can apply. Split by what? Let's say comma delimiter. Split function will return me a list. From that list, let me get the -1 indexed element. So here it is. At least verify that there is no error till now. Now here I can check inside the for loop only, if language is found in the dictionary, we need to increase its count. So D of language, kind of a key that I want to create it and increment it by 1. If the language is not found in the else part, I need to create it with the initial value as 1. Let's go one level back outside the for loop now. So I say for I in D, print I, that's a language, and D of I, that's a count for that language. That was an assignment. So this will give me in a looping all the languages. So language will appear only once and with this incremented count. And in one go, you can print the language data is D. Let us check, does this work? So here it is. As a syntactical error, indentation, if you don't follow, it gives me a syntactical error. So here it is. This was the expected output that I mentioned in an assignment. Alright, so given a problem statement, now you should be able to proceed with coding on Python. Alright, with this we have come to an end of our second part of the session, where we learned about functions, modules, packages, exception handling, file handling, object-oriented programming in Python, and various standard libraries that are available in Python. Here are some links for your reference material. If you have any queries, post your questions under the comments tab just below this recording. You can reach out to me at this given below email ID. Thank you for attending Overview of Python session. It was a great pleasure teaching you all under this platform. Wish you all the best for your projects for Smart India Hackathon. Bye-bye.